So what's up? We back. Another day, another stream. Let's get it. We're gonna get into some resume reviews, but just let everyone stroll in. Let me hit up the Discord real quick. Turn that down. Go my Discord. Luis, what's good? Let me throw the chat on the side again. Pop it out. Luis, what's up? Yo, Harold, what's good? Let me tell the Discord I'm live. Francis was good. Gonna send this over. Okay. So today I got a few people that I'm gonna run mock interviews on. Then I got some people who want to get their resume reviewed. And then probably just gonna read through some of my system design notes. Let's see. Let's just stretch this out. Let's read some of the system design notes. So requirements gathering. Just need to brush up on this before I forget it. Here, let me move myself. Let's see. I need to check the chat. Who needs to get their resume reviewed? Where they at? Type in the chat if you want to get your resume reviewed, and then throw it in the Discord. The Discord is linked. Oh, Herod, you dropped yours today? Did you anonymize it? Let's take a look. Oh, it's got a lot. Which one is you? Are you the latest one? Mod, what's good? Okay, let's take a look. Squid Kid plays. Where are you based, bro? Yeah, rest in peace TikTok, man. That's crazy. Okay, let's look at some resumes. Here. It's a picture, okay. Let's see. What do we got here? Bachelor's of Science, Computer Science. You got all your links here at the top. Let's see. Coursework, data structures, programming. What's here supposed to be in the green? Top links plus project links. Ah, I see. So use Next.js, React.js, TypeScript, AWS, Tailwind, Git. Rebuilt a 20-year-old. So you're getting internships, huh? You've already worked in the industry? That's pretty good already. Rebuilt a 20-year-old travel notice application, transitioning from a monolithic architecture to a cloud-based microservice design, reducing technical debt, and improving maintainability. Utilize Next.js, React.js, and TypeScript for logic and server-side rendering. What's this? You had intern past summer, but I'm 500 asked for summer, no offer. Are you... Bro, hop in the voice chat. Are you in the... Hop in the voice chat if you're down. Otherwise, I'll just read this. In the lounge. It's easier. Alright, it's all good. It's all good. So... Is the market worse this year or what? Because you had internships before, but all of a sudden you said you're not getting internships? That's crazy. So what is it? It's about to hit, it's 2025, so you're graduating next year. So you pretty much have this summer and then you're going to do a new grad. So you're, I see. So you rebuilt, wait, let me... This looks like it could be broken down into 2 points. This one I got through school, but I was 400 plus asked for. That's crazy. Okay, let me see why. Where are you based and where are you applying? So you're based in the what's it called? Boston area or near? So you're down to work the Bay Area, New York, Texas. I think when I look at your resume though, it looks very focused on front end, or sorry, not front end, like web development. So, and kind of front end, rebuild, wait. What cloud-based microservice or which cloud did you, was it on-prem or something or no? Maybe you could be more specific on what you did here. Besides, I mean, rebuilt a 20-year-old, that kind of makes sense, but transition from a monolith, not on-prem, but they had Microsoft built out before I joined. I see. Utilize React for logic and server-side rendering. Achieved 80%. Deployed to multiple stages, like... Collaborated. So the one thing... Reduce technical time. The one thing, you do have your results. Your bullet points are results oriented, but the results are at the end. There's a video here. I always go back to the same video every single time from Google interview or Google how to build resume. Google how to build resume.
Here's another example.
So one thing you could try out with your resume is reordering, making it more results oriented, because I think right now it's less you do have your results there, but this video, and I'll send it in the chat, kind of outlines how you should structure your bullet points. So it talks about accomplishing X as measured by Y by doing Z. So let's see how, let's like take a quick screenshot of that. I see. But even here, so this is kind of what you did, which was rebuilt. But what you achieved is you reduced the technical debt and improved maintainability. So yeah, just make him up. Yo, Paul, what's good? Yo, Paul, you ready for a coding interview? Or what? You gonna hop on today or what? So so here you could switch it around. Say something like you reduced technical debt and improved maintainability by transitioning from a monolithic architecture to a cloud-based microservice, or accomplish X as measured by Y. Let me see. Let me see what my resume bullet points kind of look like, because that's kind of how I structured it. Okay, wait, utilize. I think you follow a lot of the same, like you have a lot of the same type of technologies as me. So let me share mine quickly, and then I'll let you take a screenshot. Let's see. This is like kind of like mine, but I don't. All my internships are kind of at the bottom. So I say what I achieved. So for example, I increased the accuracy of an object tracking system, and then I put the measurement, which is by 20%, and then I say how I did it by implementing K-mean filters to approximate the locations of objects under occlusion, for example. Or pretend I reduced the build times, right? This is what I accomplished. I reduced the build times by 50%. So this is what I accomplished, and this is the metrics. And then I say what I did to do it. That's kind of how I structure all of the different bullet points. Oh, did you get a screenshot or no? I'll let you take a screenshot. That might help figure it a bit out. And you could like send it. Yeah. So yeah, let's see, develop. Do you have experience I feel like a lot of it is Next.js, React, TypeScript, which is still hot and a lot of people use it, but probably I would mix it up as well. Let's see what you don't have. Let me see if I was hiring you for my startup. So, are you trying to land big companies, small companies, or medium-sized companies? Yeah, I think Python is really hot right now. I see, I see. Where are you from? Nice. So you're trying to get like an H1B or something? Oh, you probably need OTP. That makes sense to focus on that. Deploy to. I mean, when I look at your resume, you're definitely doing a lot of things that are needed in order to do well at a job. So, for example, you've deployed to multiple stages, yeah. Collaborative product management to test. I would make it more. I think, let's see. Yeah, the one thing is some points. Dang, he's 18. My resume at 18 was. Are you 18? Who's 18? Who's 18? Does it say? Alright, he's still 20. Yeah. Mine wasn't this good. Yours is still good. I literally have no idea why you don't get developed the web by programming detecting. Is that the real LeetCode hard or the fake? Yeah. What do y'all think about the resume? What are we giving it? What's some advice? Yeah, honestly, yeah, I think it's a solid resume. Pick up Harold. I don't know. I'm not sure if that's the case, but what you should do is I think the bullet points could be more results oriented. The more I look at it, I think it's very focused on Next.js and React. Pretty much all the bullet points involved Next.js and React. Maybe mix in some Python and just show some diversity because you're still early in your career. Sometimes they like somebody who's more of a generalist. I don't know. That's just me just saying random stuff. But yeah, also try to reach out. Definitely do, if you're not getting interviews, definitely start cold emailing people and finding ways to get referrals and all that stuff. Because cold. Yeah, just putting it in there. I don't know. What I'll say is when I was graduating, I tried every possible way to get a job. Just hitting up the if I sent in my email or if I sent in my application, then I'd go look for recruiters. Yeah, I'd apply directly on the website. Then I'd go talk to recruiters. Then I'd go try to join some of these fellowship programs. I'll send you this. Yeah, you just gotta keep shooting your shot, honestly. Here, I'll check this out. Yo, who did the... Yeah, that... But otherwise, I think you're hitting some good technologies. And everything's there's nothing that stands out that's terrible. I think it looks good to me. I would just say make sure you improve the bullet points. And improve the bullet points a little bit. Yeah, probably improve the bullet points a little bit. Maybe if you maybe if you like had these are indented pretty far. Maybe if you move them back a little, you'd make up a little bit more space, but I don't know. Other than that, I think the content is decent. Like you already are hitting a lot of the good technologies and stuff. That's all pretty much I had to say today. Kind of some lead code questions. Let me check the chat. Wait, let's look at some other people's real quick, and let's see. And then maybe you'll get some maybe you'll see what how others people's looks. Ruben, what's good? Nice to see you again. So this person has computer science and data science. They have a 4.0 GPA. They're expected to graduate pretty much same time as you. Okay. I got you. Bro sent it in straight LaTeX. Okay, wait. Let me download it. Yo, Squid Plays is good. That's crazy. Okay, we'll finish Squid Plays. So it's transcript off-topic classifier, trained latent semantic indexing model to classify off-topic segments in video lecture transcripts integrating natural. Nice. Yo, Squid Kid, how come you have some dots to finish them and some don't? I would just make sure that I have dots, or I'd just be consistent with the periods. Yeah, probably adding some metrics. Indent the points too. Okay, you got some of your experience. Bro, I would remove the soft skills. Yo, E, what's good? You ready for a mock? You ready for a mock today? I would take out the soft skills, honestly. Take that out for sure, Squid. Yeah, take out that. Yeah, soft skills, I've never seen that. Yeah, mocks today. Hey, everyone's rolling in. Mocks today. 100%. Wait, I'm just checking over my stream. Yeah, we'll get some good mocks in today. Give me a sec. I need to put up my stream somewhere else. There you go. Yeah, we're gonna run them after the next resume. But I would say definitely Squid Kid. probably more metrics. I think if you can't find any metrics, try to really dig deep into what the metrics can actually be. I had the same problem when it came to, because I had some machine learning AI stuff related to mine as in mine as well. So trying to figure out exactly what metrics to have, I had to really think about it. So let me just show you some of the metrics that I had. For me, with a lot of these, I had to really think about what metrics that I had. So I think I had some. So this one. So here, for example, instead of just saying I built an exercise detection system by using a CNN and pose estimation, essentially, I also talk about the accuracy. So I say I achieved a 96%, 98.6% accuracy on an exercise detection system. You see what I mean? Instead of saying I developed this, I also can talk about, yeah, exactly what Supercrack said. Like bring some of the actual metrics. So for example, instead of just saying that I increased the speed of an object tracking system, I say exactly how I did it, which is, or how much, which is 30% by multi-threading all IO bound processes, something like that. And then this one's also, so exact, instead of saying like I implemented K-min filters to approximate locations, then I'll say exactly, or this is what I accomplished, right? Increase the accuracy of an object tracking system by 20%. I say what I accomplished. Okay, I see. Okay. Yeah, I'm. It's hard to come up. It's hard to come up with metrics, but you have to think really deep about it, honestly. How do you measure that 30% by timing? Yeah. So if something takes 100 milliseconds and you can cut it down to 70 milliseconds, you sped it up by 70% or 30%, right? So yeah, like some of these, I had to think really deep in order to figure out how to add metrics to it, but I think metrics are really important. So I think that's one thing you're missing on yours, and the content is very, very solid. It's more just, yeah, I don't know. Wait, see, let's look at one and try to optimize it, and then you can go from there. Okay, when you said to improve topic identification and model performance, could you be more specific on how much it improved or something like that? Let's see. Yeah, how much did this improve your model when you did this? Let's see. Created created a hackathon through team collaboration. Yeah. I would say definitely make the bullet points more results oriented. That would just be my only thing. More results oriented and more results oriented and more, like I tried multiple models and also tried different pre-processing steps. Yeah. A Linkwitter project usually might have to go back and check how much better it got. Yeah, or you can make it up, honestly. But what I would say is make the bullet points more results oriented and add metrics. We'll just add that here. More results oriented and more metrics. I mean, sometimes it's not possible. I think it's easier once you start working in the industry to figure out the metrics, because that's something that you actually have to provide. You know what I mean? Okay. Utilize. Yeah. I think it's still good. Sometimes, and I've worked with people to build their resumes, especially when they're still in school, and sometimes it's hard to make it really results oriented, because sometimes it's just harder, honestly. It's a bit easier for when you actually are working, because everything you do has to lead to some result. You know what I mean? Cool. Let's move on to this next guy. Who's that? Francois. Then we'll get into some mocks. Wait, let me fix this. Okay. Hop in the lounge. Hop in the lounge. Let's have a chat. Let's talk. Voice and video. You hop in the lounge.
Hello?
What's up?
Yo, thanks for having me.
What's good? Let's check this.
All right, thank you.
No problem, bro.
For a little bit of background, right? Like I said, in high school, looking for like an unpaid internship for my diploma, because in Ontario we have like a co-op
Bro, I
program.
could
in
tell
our
you're
high-
from Toronto off the jump. Let's see.
Yeah,
Yeah.
damn. But yeah, so basically we have to work at a company unpaid for a few months, and then it just counts to like it's a credit for high school.
I see.
So for this resume specifically, like ATS doesn't really matter because I'm not going to be applying directly to jobs, obviously. Wouldn't really be qualified for that and for the pay and stuff. But so I'm thinking, I don't know, should I do like a more creative resume? And also I was just wondering like about like optimizing the bullet points and stuff. But yeah, I'll let you look at it, I guess.
Let's check it. So
Thank you.
you're from Toronto. You're graduating in a year?
Yep. This is my last year. Yep. Grade 12.
Oh, wait, you're graduating high school?
Yeah.
No. Oh, no way. So, wait, what's happening? You're trying to get a job right away? Or you're trying to apply?
No. So to finish my diploma next semester, I'm doing a co-op program with my high school, and I've got to get an unpaid internship.
What?
And if I don't find something myself, they're going to give me something stupid like Best Buy, you know?
Yeah.
So I got to like work on looking for stuff myself.
What kind of high school is this? That's crazy.
No, like I think every school in Ontario has it.
Really? They make you do that?
Yeah.
All right. Okay, let's check this.
No, you don't gotta, but like I like opted into it, you know, because I
Right.
feel like it'd be good experience.
I see. Okay. Let's walk this thing top to bottom. Wait,
Okay.
what school did you apply to already? Are you gonna go to uni?
Yeah, I applied to Waterloo, U of T, and then like smaller ones like York and Carleton.
When do you hear back?
I heard back from York and Carleton, and then Waterloo, U of T. I think like March, but realistically for me, it's gonna be later around probably. So like maybe like May.
What are they saying? For the
What do you mean?
schools?
What are they saying?
Like are they gonna?
I got in.
Oh, go ahead.
I got into York and Carleton. Canada though, basically if they answer you, that means you got in until it's like June.
Okay.
Yeah.
I like this. All right, let's just go step top to bottom. You're still in education. For a high school kid, this is crazy already. I feel like you already have all the sections. So
Thank you.
maybe I would remove the personal. Like I already
Alright.
gave somebody that feedback before.
Yeah.
Because
Right.
based on your bullet points, you could already tell that you can do all. Basically, the results that you drive from your bullet points should show a bit about how you are as a person. You know what I mean?
Right. Yeah, that makes sense.
So let's just hop into this. Create a TypeScript plugin to automate the Obsidian note-taking app, saving over 100,000 or 10,000 user hours daily. I would flip this around so that the results are first. So if you flip this by saying something like save users 10,000 hours daily by creating a TypeScript plugin to automate the Obsidian note-taking app, it pops out a bit more because, or the first thing that somebody reads is the results that you drive, and a lot of these companies, they want people who can drive results, and that's why they try
Right.
to focus on results oriented. But you do
Yeah.
have good results there. And I'll show you. Let me pull this up. See,
Yeah, that's a good idea
you see
for
this,
that.
right? This is by Google. A lot of people that I know, they use this. I use this as well to build up my resume. But if you take a look, it says try to do it like this.
Right. Okay.
You
Okay.
accomplish X as
Got
measured
it.
by Y. So what you accomplish here is you saved people 10,000 hours, right? That's what you
Yeah.
accomplish. And then you say by doing Z. And what did you do exactly? You create a TypeScript plugin, right? So I like that format. So that would just be a suggestion to try out, because
Right.
yeah, that's how Google likes their people to write it. So like, you see, you have a lot of this stuff there. I just try to flip it. Be like,
Yeah.
reduced production bug report by 50%, for 50% release to release by implementing Jest unit testing. Bro, your resume is good, but
Okay.
I
I
would
got
just
it.
flip
Got it.
it.
Yeah.
You
That's
know?
actually like way better having the stats first. It makes sense.
Yeah, because then if I'm just reading it, I just start pretend I'm reading it from top to bottom, and I don't want to read every sentence, right? Then if I
Yeah.
start just reading it top to bottom, essentially I'm just start seeing I can just start seeing all the results that you had. Imagine on the left, it's
Yeah.
just like 10,000 saved 10,000 hours, reduced by 50%, was picked out of 288, and I'm just reading it from top from the left side, because people have a short memory. They might not even read the whole bullet and see.
Yeah. Right.
Yeah. Yeah, I don't know. Your resume is good to see. Your math tutor too. You don't do you put dots on purpose, or don't put dots on
What do you
purpose?
mean, like
You don't put the dots
dots on what?
at the end of each
Oh,
sentence.
at the end of the bullet points?
Yeah,
Nah. I mean, I could though. I don't know.
I don't know.
Yeah,
Chat.
someone in the chat said bold the metrics. I was gonna ask about that too. Do you think I should do that and the programming languages and stuff?
I feel like that's how I do it, because it makes it pop out a bit. But some people say they don't like it, but I like it.
Right.
So you applied to a bunch of CS schools?
Yeah.
Yeah, different people have different opinions, honestly. Bold and but people are telling you to bold. It's like 50-50 right now. Be prepared to answer on how you
Yeah,
say
that's
it.
the thing. I search it up. It's like everything's mixed.
Yeah. I bold mine and I got interviews, but I don't know. I feel like the resume. I don't even know if people are looking at it these days.
Yeah. No, they're not asking for my resume. Someone in chat asked.
Let's see. Do they ask for it? I've been a senior. Let's get saying.
Some schools have like supplementals where they ask you questions about your ECs and stuff, but that's
Yeah.
like only Waterloo, U of T. Everything else is just off grades.
Nice.
Yeah.
What's your plan? You're just gonna go to school, or are you trying to move out to the Bay or New York or something? Or you like Toronto?
I don't know. See where it takes me. Toronto's good though,
Yeah.
but
Toronto's
obviously
nice.
there's more money in Cali and stuff. So
Yeah,
whatever
there's a
happens,
lot of money in Cali.
Yeah.
I'm from the west coast of Canada, so.
Right. That's cool. That's cool.
But yeah, otherwise, okay, let's look. Collaborate with a. Yeah, that's the one thing. I think all the stuff you hit is good. Create a blazing fast. Yeah, the ones with the metrics, I just flip it. If there's not really metrics, I feel like when I'm looking at it, it reads well already. Create a blazing fast. um. Yeah. Okay. Good job, man. Let me know. You got any questions though?
Do you think? Okay, I have a few. I have a
Yeah.
few just
Ask. Just
quick.
ask as much.
Should I remove the tutor experience and put like another one of my like side projects I'm working on?
Bro, you got a few side projects already. Let me see.
No, not that one. The one under experience, the math/code one. Yeah,
This one?
at the bottom of experience.
Oh, okay, okay,
Sorry,
okay.
my stream's delayed. I can't see, but
Oh, shit. So you have projects and experience. Let me see. Bro, you have like actual experience too.
it's a really small company. It's something local, so
So wait, I think you'd be able to get a job as a high school student with this.
I don't know. Okay, so I haven't reached out that much yet, but reached out to a few big companies in the city, but I'm starting with big though. I'm starting high. I reached
Yeah.
out to recruiters on LinkedIn, ghosted. No messages back. But I'm gonna reach out to smaller companies too. That's more realistic. I just have to see what happens.
Yeah, I would just say just keep throwing it out as much as you possibly can because it's a
Right.
numbers game at the end of the day. But I
Yeah.
think your resume is solid. The spacing is nice. You're hitting all the different stuff. I would just flip it. I would just make it. Yeah, just get the metrics popping out right away, and then I don't know. Try bolding the metrics and see if it looks good. But yeah, everyone's saying high schooler is crazy impressive. Like, yeah, just literally
Yeah.
apply to everything. It's a numbers game. You could have the best resume ever, and I don't know. Like a lot of these companies get so much applicants, so
Yeah,
yeah.
that's the thing. Like, I'm sure most recruiters don't even check their LinkedIn. They're probably getting like 500 messages a day. So I need like a better idea for like cold emailing or whatever. Do you have any like tips on that or?
Dude, just message once you send something in. Look for people who are working at that company. Look for people who are also not just work. Look for recruiters. At the end, like also when I was graduating, even though recruiters ghosted me, I would still send a request, and then
Yeah.
they would still add me, and maybe 3 or 4 years down the road, I could hit them up. So
Right. Yeah, that makes sense.
it's never bad to just connect with someone, even though if they ghost you. Maybe some time down the line, you might run into them, or you might be able to message them because now they're already part of your network.
Right. Okay.
And also, LinkedIn is the more connections you have, I feel like it's better. It's like SEO, you know what I mean? Like if you have a lot of connections to a bunch of different recruiters and they start looking you up, you're gonna be popping out right away. So I would
Yeah,
just there's no, even though if they ghost you, it's not really the worst thing because now you have a recruiter in your connection network.
that's true. That's true.
Yeah.
Yeah, I gotta work on my LinkedIn. Low key, it's like I have like nothing on it right now, and my portfolio site too.
Yeah, he's saying it's proven that connects equals rank higher in searches. Yeah, it's like SEO.
Damn.
Like you just gotta connect with people. You gotta hit people up. You gotta email people. I mean, you could use ChatGPT to email people. And I don't know,
Yeah.
just throw it out as much times as you can. Bro, I was applying to like 20 places a day when I was about to graduate.
Damn.
I don't know. What else you
Someone
got?
said someone asked how effective it would be to go to companies in person and ask if they're hiring. I was thinking of doing that too, but isn't it like a lot of those companies have like security and like those gates and shit? Wouldn't it be kind of weird to just go in and ask? I don't know.
Let me think.
Not sure.
Yeah, I mean, this is it's a new age. I feel like I
Yeah,
used to do that
exactly.
when back in 2010, but I don't know. Everybody these days, I feel like at 2012, James, you graduated during COVID. I graduated in 2021. But I feel like these days, just apply to as many places as you possibly can, bro. That's literally my
Right,
advice, and I think your resume is already solid, so it's more just getting it in front of as much people as you possibly can. Maybe I would just
right.
remove the personal part, but it's not even a
Good.
big deal. That's just a nit. I mean, it might be better for high school kids, but
Yeah, I don't know.
you already have a GitHub. You have all this stuff that even kids in first years don't have. So I think you're good with this. Yeah,
Yeah,
and
I
you
guess
already
just
have
got to get it out
leadership.
more.
Yeah, let's see. The leadership part is really nice too. Honestly, it's a solid resume. I can't lie.
Thank you. All right, so basically, so remove personal maybe, and then bold metrics. Should I bold programming languages too, and like technologies that I use?
Let's see.
Hello?
Yeah,
Oh,
I'm
sorry.
just taking a quick
No,
look.
my laptop just died. I thought I was on call on my laptop. I forgot.
No problem. Run this thing through GPT because it looked like there's a spelling mistake there. Collaborate with a fellow. Oh, never mind. My bad. I just read that wrong. Collaborate with a fellow student from Hungary to create an app to decent wrote React front end that won second place overall. Yeah, I don't know. Your bullet points are good. I have no real feedback on this because everyone's already saying for a high school kid, this is really good.
Yeah. I'm just ambitious, bro. But you know what? I'm just gonna like keep sending it out and improve on what you said, and just just hope for the best,
Yeah,
I
you
guess.
got this,
Worst
man.
case, I'll work at Best Buy or something, you know?
Yeah, it's just it's as long as you get something under your belt. How are you? Do you know what lead
Exactly.
code is already or not?
I've done like a few questions, but I
That's
haven't been like
crazy.
doing it that much, you know? Not at that level yet.
That's wild. Yo, Mohit, what's good? But that's wild. That's
When I was
crazy.
like grade 10, I was looking into like data structures a lot, like like breadth first search and like trees and graphs and stuff, but at
Yeah.
low key I forgot everything. I'm rusty.
Yeah, I mean, that's already way ahead of everyone who's gonna be in university, honestly. I didn't even know what programming was when I got into uni. So,
Damn.
yeah, everyone's saying this is a resume of an 18-year-old. That's crazy, bro. But yeah, that's
Thank you, Chad. Thank
everyone's
you.
already saying it's good. So I wouldn't make any more suggestions. I would just say if, yeah, exactly. What Mohit's saying in the chat. I think
I
it's
can't read it.
solid.
My laptop died, bro.
Oh, it's
I'll
all
look at it
good.
after.
Yeah, everyone's saying it's solid. That's what I mean. If everyone's saying it's solid, it's solid because usually the chat is a bit tough on the resume sometimes.
All
So
right. Hey, thanks so much. Then I'll
no
improve on
problem,
what you
bro.
wrote, and I guess just keep spamming recruiters and whatever CEOs and stuff, and just
Yeah,
hope for the best.
yeah. And I'll hit you
Yeah.
up soon. We'll let's do a live coding interview at some point on the
Okay.
stream.
Okay.
All
Bet.
right, I'll hit you.
Yo,
Okay.
I have exams next week. Give me a few weeks, and I'll
All right.
definitely be down.
Sounds good.
All right. Bye. Thanks so
Okay, no
much.
problem, man. E, hop on the chat. Paul, somebody hop it. Who's trying to get a mock interview? I'm not a recruiter, so I can't do these resumes all day. But I know. E, what's good,
Yo, it's good.
bro? How you been?
Good, good.
You ready for some? Okay, Super Crack Dev is next. So, E, tell us a bit about yourself. Where are you based, and where are your lead code skills at?
So, I'm from New York. I'm gonna intern at JP
Nice.
Morgan this summer. My LeetCode skills are not that good, honestly. Like, I'm at 100 questions right now.
I see. I see. Okay.
But, like, I take a while to try to, like, look at patterns before I, like, just start grinding out, like, just a bunch of questions.
I see.
So, I mean, I think I could barely solve like a new medium type stuff.
Okay.
Yeah.
Okay. We'll kick it off with something a bit easier, and then we'll go harder and harder we'll see where you can get to. So did JP Morgan ask leak code they're asking?
They asked like really easy stuff. So basically, the first question. This is for answer, by the way. So it was like intersection of an array, which is like
I
an
see.
easy like textbook one, and then like a max subarray, and that was it. And then the rest were like just like skill questions and stuff like that.
All right, let's just hop into this then. I'll send you a link. Let me pick a good question. Let me know if you did this question first.
Like,
How did you end up practicing any of the backtracking stuff that I was teaching on the chat or the stream the other day?
oh yeah. The for with the template basically you showed,
Yeah.
yeah, no, it was super useful. I was like, it goes for every backtracking question. You weren't even trolling. Like,
Yeah.
it was like actually super helpful.
Yeah, you can use that same template for everything, literally.
Yeah, I was using that for like a bunch of different questions.
Okay, let me look for a nice question.
Oh,
So you're just trying to study patterns first, and then
I remember I had a one LeetCode account where I solved like around like 200 questions,
Oh,
but
wow.
then like I didn't understand any patterns. So I was just like solving and getting lucky.
I see.
So then
I see.
like this past like end of 2024 when I started like locking in,
Yeah,
I started focusing on patterns like 100%. And yeah.
I see. I see. Okay, let me. Let's see. I'm trying to figure out a question. I see a few good candidates. How are you with DFS? Let's see how. Let's warm up your DFS. Hop into this.
Ooh. Oh, where are you sending it?
I'm gonna send you a link. Give me a sec.
Okay.
Let me send you a link real quick.
Oh, I already all right, I think I already
this?
solved that. Yeah.
Let me see.
Number of islands?
Yeah.
Yeah.
Okay. I got a better one. I got a
I
good
think
one.
I would fumble on there right now.
I got a good one that can test your. We'll test your decimals. Okay, I'm gonna send this.
Oh, okay. Okay.
Alright. I sent it to you. Hop in.
Alright, I'm
Making a large island super cracked. Loved, I don't run a startup.
Alright, I'm in.
But alright. Okay, what are you thinking?
Alright, so I just start, right?
I mean, explain what you're
Okay.
thinking. Let's
I'm
treat
gonna
it
read the
like a
question
real
real
interview.
quick. Given two non-negative integers, so positive. I don't know why they put that, but num1 and num2 represented as a string. Return the sum of num1 and num2 as a string. You must solve the problem without using any built-in library for handling large integers.
Yeah.
You must not convert the inputs to integers directly. Does that mean, wait, when they ask this, does that just mean you can't use you just can't use int for the
Yeah,
that?
you can't convert both of them into integers and just add them, you know what I mean? And then convert it back to a string.
Oh yeah, okay. Let me. Okay, this is from Meta.
What are you thinking?
I can't convert inputs to integers directly.
Yeah, it's a good thing to ask, but it makes the question too easy.
Wait, so like that means that you could convert like individual like characters to integers, or
Yeah,
like.
you can do that.
Oh, okay. 'Cause I was so confused. I was like, how is that even possible if you can't even convert anything? Okay. So I guess you can go like character by character in a string and like turn it into its integer representation, then add them.
Sure.
And then wait, you cannot convert, but you can convert them back to strings, right? I assume because it doesn't say that you can't.
Basically, just don't take the whole number and convert it to integer. You can work digit by digit, whatever way you feel like
Okay.
it. Yeah.
Okay. I guess. Is that a good approach though? Just like converting it to integer character by character.
I think that makes sense, but could you be more? What are you gonna do after you do that?
Like, I would multiply by have like a variable to like turn it into the integer, and then like each numbers place I like multiply by 10, and then so it could like have the digits place match up.
Okay. So you're trying to multiply by what do you mean specifically by that to make it match up? So are you gonna compare 1 and 1 at first?
Wait, what do you mean?
So okay, so just walk me through the algorithm that you're thinking about. I'm a bit confused of exactly what you're trying to.
I low-key think I'm overthinking. I actually I'm trying to like think of something like actually good.
Yeah. Okay. Let's. Okay, let's walk through a couple. So if I ever get stuck in an interview, right? I literally just start walking through a couple test cases. So let's start with nums 1 and nums 2, and then walk me through how your algorithm will produce the
Okay.
output.
So I would take the one from like the beginning,
Okay.
and I would add that to like a variable. Wait, I don't know if chat's like saying anything because I'm not looking at
No,
that.
it's all good.
Wait, let me.
Don't worry about it. Don't worry about it.
Yo, wait, can you hear me?
Yeah, I can hear you. You're good.
Okay. I guess I would start it at 0, and then I would add the I guess I would start from the end of the string to the front, and then I guess I would add low key.
Okay, so you're gonna work from the back, right? Why would you do that?
Because it's the lowest place.
Okay. Yeah. So we're just gonna do basically elementary addition, right?
Yeah.
Okay. Let's walk through this then. Say we have the result here. And then walk through how you would do the addition.
It would be 1 plus 1 times 10.
1 plus 1 times 10. Why don't we just pull out the work from the back like you mentioned, right?
Yeah.
And then just convert these two into integers and then add them.
Oh, wait. Oh.
Love, you can convert to an int. You just can't take the whole thing and convert it to an int.
Oh, I was converting the whole thing to an int like 1 by 1, and then having that in the result, and then just adding that like same process from num2.
Basically, you can't just go like this, essentially.
Yeah.
But like,
Yeah.
if you want to pull out a character, that's still fine.
Okay.
So what are you thinking? What's your approach here?
Oh wait, I think I did this before. Wait, I think there's like I remember I did this on a OA, and then I did something where I did like a string method with like a zfill or something, and like I made it so like they're both equal length, so it's super easy to add. There's like a helper. Wait, I think it's called zfill. I think like you find out which length is longer, and then you can just return the
Yeah. Okay.
you can just return the method like with it swapped, just so like it's like it works for both cases.
If the length
And then
number
you could-
2. Okay, that makes sense.
Yeah, and then you can
So you want the bigger number on the top, essentially.
yeah, and then you just turn the smaller number to match. So you would do I guess I'll put equal length is equal to and can I print
Yeah.
like
Okay.
what will
Let's
come
think
out?
about this a little bit. I feel like we could just work from the back like this. Do we have to do the addition in place, or we can get the integers for both and then add?
That's what I was thinking about. I was trying to get the integer for both, then add.
You're gonna
That
get
was my first. That's why I was doing this like kind of messy thing here.
Kanye East was good. Let's see. Because another approach, the way I another thing that you could try is reversing them, so you get the least significant digits at the start.
Oh yeah, yeah.
I mean, I would experiment. You could work from backwards. You can work from, but if you want to work from the left to right, you could reverse them. That's one way. That sometimes makes it simpler. What do you think?
Yeah, you could the reverse one makes sense too. But I think I did it this way, and it passed all test cases on like OA.
What's num2 z fill length?
Yeah, I was gonna print it out to see what it would.
Okay.
But it basically what it does is that it matches the length of like, it like, if the string has a smaller length and you input the length as like a parameter, then it'll just like put a bunch of zeros in the front.
I see. Okay, let me give a small hint here. Right? Pretend we have a result. So essentially we have a result, and at the end we want to pretend the result is this, right? So we start at 2 pointers, one at the nums2 and one at nums1, right? It doesn't even really matter what order they're in. Let's just say they're in this order, the reverse, right? So we look at 1 plus 1, or we look at the first digit. These are the least significant digits of the integer, right? So these need to be added together. What's 1 plus 3? It's equals 4. We can throw that into the result here. And we can move the pointer here, right? What's 2 plus 1? 3, right? This one we can move it off, and basically we could just have a check. If it's less than 0, treat it like a 0, right? So now we're comparing 0 and 1. What's 0 and 1? 1. Right there. Right? I mean, then we can pretty much just reverse it and return it. Essentially.
Yeah. Yeah, I was overthinking it like crazy before. But yeah, I get this. Oh, this is kind of like that linked list question where you add two two numbers.
Exactly.
It's basically just like that.
Try it out.
Do you still want me to code it or like?
Yeah, try it out.
Okay. So you just reverse both.
I mean, you don't need to reverse it. You can work from the back, but yeah, you can try reversing it. Just if it makes it easier for you to think about, try reversing it.
Yeah, I'll reverse it. Can you even reverse strings?
Yeah.
In Python?
Yeah, that's good.
Oh, you can?
What's your language that you like to use? You like to use Python?
Well, I use Python, but like sometimes like strings are kind of funky because they're immutable.
I see. So you reverse them. Now we have something like 1 1.
Oh yeah, you need to have like a pointer for the 2 pointer. I think.
Yeah. Nice.
No. And then we can have a carryover. I'm gonna do this later, but I do remember something about being a carry.
Yeah, let's fit it. Which later? Oh, that one right there. Okay, this is good. It all looks good right there. Keep going.
Okay, so then we can get the just call it A, and then we just converted that one to a then we can add it. I'm guessing like I'm not gonna worry about carries right now. Just like trying to get something to work, but at least pass the first test case.
Yeah.
Let's put a string.
Might have to reverse it.
Oh yeah. Let me see if it at least runs. Unterminated triple quote. Oh, I guess yeah.
Oh yeah,
Sure.
delete that. Delete that.
Yeah, no, I thought you couldn't reverse strings.
You could reverse the string.
Oh wait, Loki, wait. So you could do it with is it num1?
Oh yeah. No, you could do num1 dot reverse, something like this. It returns.
It returns?
Yeah.
Oh. I thought it's in place. I thought reversed it returns.
Wait, is this wait? I think there's 2 LeetCode hards in the chat. Okay, wait, run it. See.
What the heck? Oh, it's still there. String has no attribute reverse. Wait, let me try. Wait, I think it's like this.
Yeah, that works too.
But thing is, I'm pretty sure it returns an array. Let me see. The heck? Let me try the this one.
Oh, this triple quoted string is tweaking. Okay. Let's run it. You're not incrementing your pointers.
Oh, I'm actually washed. That's the problem. Okay, we passed one. Oh, okay, that's horrible.
Let's see.
Oh, I think at the end you have to like account for
Yeah, you're not. Okay, do you understand how the carries work?
Yeah. Why is this more stressful than an actual interview? What's going on? No. No, this is actually sad. I'm fumbling to this.
Okay, you're adding A plus B, right? Okay, let's walk through this example. Come down here. Right.
Right.
Pretend we're comparing 9 and 9. Right.
Yeah. I know how to do it. It's just that I'm like going through it right now.
Yeah.
That's the.
Try to add the carry here.
Okay, so we have to first like get the carry though. Yeah, we have to get the carry from it as well. So like if cur is greater than like 9, I believe.
Yeah.
You could do greater than 9, or you could do like some division logic. And then you could get carry is equal to what I think cur minus 9. And like cur.
Or just say carry equals 1 at that point, because.
Oh yeah. Okay, yeah. And then.
And then another one hint I'll say is you're going out of bounds here. Handle out of bounds here. Nice. I like that. That's clean.
And then you have to before we append it, we have to get so that it's only do it. Can we just do? Is that how you get the just the integer from it? If it's greater than.
You're good. That's
Okay.
good.
And then we have to handle the case where like one finishes before. So like if I less than I think we could just like while we can just do
Is accessing index before going if check. Super cracked. I think it's good. Wait. Let's see where we get here. Reverse.
wait
What is
you
this?
where?
Or wait. Let's comment this out real quick.
Okay. Are we getting a runtime error?
Okay. Expected. The output is here. Everything's kind of working, but you're just not handling what happens at the end.
That's what I was trying to do with the while loop at the these two while loops then?
Wait, somebody said fix line 11. Fix line 11 as well.
9/11. Oh, is or
Yeah,
and?
it's or.
Oh, okay.
Oh. I think it will work for this case, but there's one edge case that you need to account for.
The while loop's not doing that? The one that you just deleted?
Basically, at the end of it, right?
Yeah.
Pretty much at the end of it, there might be a carry left, so you need to cover that case, right? Pretend
Yeah.
pretend you only have 9 and 9.
Oh yeah.
Or I mean, usually just try to handle it at the end of the while loop.
Oh. Thing is, it'll automatically be handled though, cause
Super cracked.
with
It
this,
doesn't.
I think,
This
right?
ternary, it's gonna evaluate this, and then you only do this if it's true, and then otherwise this, so it's good. Basically, just handle the carry down here. Is what I'm saying.
Okay, I'm tweaking. Okay.
But code's looking solid.
Okay, handle carry down there.
Yeah, handle carry down there.
Wait, can I just put else carry 0 up here or no?
Well, I mean, okay, let's walk through this case. 9 plus 9. What happens? It's gonna do 9 plus 9. You're gonna have a carry, right?
Mm-hmm.
So you're gonna get 8 here. So let's just add the test case 9 plus 9 real quick, and let's see what you get. This should be 18, right?
Right, it doesn't show up for me when you add test case. So
Okay. Oh, really?
Yeah,
Wait.
but you're putting
Why is
9
this
and
slow?
9. Okay.
Memory limit exceeded. Wait, what happened?
No, because I added the
Oh,
carry
okay,
to
okay,
the
okay.
to
Remove that,
here.
remove that.
I was gonna handle it there.
Did you see it right here? You get the test case or test case 4?
Hold up, wait. We have this random like dot reverse in there. Wait, all right, let me see. Test case 4. Yeah. I see it. I'm thinking if you put else here, and then you just put that extra check in the thing here, then it should handle
Let it run one more. I mean, yeah, that might work.
Oh no, it doesn't work. Okay.
All right, because
Oh wait, it does work, but I just didn't reverse it. I deleted the reverse.
I see.
Okay.
Did it work?
I mean, you could try running it on yours.
Let's see, submit. Nice, that works.
Okay.
Because what I was thinking is you just go like this, remove this if case, and basically just be like if at the end, if carry equals 1 at the end, then you just say res dot append a 1. There you go.
Yeah, that's yeah.
Let's do. Nah, good job though. We got it done. Let's see.
Damn.
Let's see.
That was tough.
Wait, what happened?
Even a question I think I did, but I think I might have did this before, and I still like giving me an issue.
If the carry is greater than 9. Yeah, I would just keep practicing because you just need to work on getting it up fast.
Yeah.
Okay, my advice would be I think the variable names you could improve the variable names for sure.
For
Because
sure.
a lot
For
of
sure,
companies will definitely mark on that as well. Shit, let me block in.
Yeah.
I would, and then what I would do is if I'm stuck, literally just walk through a test case, right? So you weren't really walking through a test case, you just kept looking at it. But the best way to get unstuck is just try to work through a test case. Because even with a question like this, after you walk through a test case, you'll see that you could use pretty much elementary division for it, which is taking the least significant digits and adding them together and then taking a carry. So I would literally just walk through how I would do that. And then you just start, once you figure out that it's elementary division, you start having to figure out what the code's going to look like. And all the things related to reversing and catching all that stuff. I think you're getting ahead of yourself a bit, thinking through all the edge cases. I would just get it working and then start fixing some of the edge cases.
Yeah. I was definitely overthinking it.
Yeah. But yeah, I think that's good. We'll run back a different one, different time, and I'll message you on it.
Okay. Bet. I need to improve. I'll improve by then. Like for sure. Like this is.
Yeah, we'll run it again soon.
This was not it.
Don't worry. I got other good ones for you next time.
All right.
Who's in the chat trying to get
here.
next? Yeah, who's trying to get?
Peace, bro.
Peace, bro. Good job, though. Okay, hop in. Paul.
Yo,
It's good.
hold on, let me mute this. Can you hear me?
Yeah.
Okay.
All right. Let's see. You were helping me out a lot the other day. Let's put you through some. Let's put you through some questions. Let me think. Are you good usually with the math things, or even the coding ones is fair game?
I think pretty much anything besides tries. Like I knew that one try. Like I know that the patterns. I just don't think I could code that.
I see.
If that makes sense, because I've only coded a try once, like ever.
Wait, let me see.
Binary question. I could probably do a binary question. I'm probably very like the math ones. I could probably do
All right.
most of those.
Okay. I'm gonna give you. Have you done 162?
Let me look it up. Peak element. Yeah, I did it like 3 years ago.
Oh, you did this long time ago. That's crazy. Okay.
Yeah, I did a few leak codes in like 2022, and then I didn't do any until like 3 weeks ago. After that,
Crazy. Oh yeah, congrats on getting your offer. How you feeling?
yeah, feels pretty good. I think I might have taken an offer too early though, because I'm getting like more interviews now that are a lot higher comp.
From where?
I mean, not a lot, like 30-40% higher.
That's a
though.
lot.
I got an offer, or I guess not an offer yet, but like it was pretty much going to be an offer at a company called Fetch.
Oh, okay. Interesting.
Like Fetch Rewards, I guess it's like an app, but that role seemed like very boring.
Yeah.
And also the OA was like that 4 hour one, like the one that was going to take me like a few hours. I think they'd probably be like one of those companies that makes you work overtime a lot.
I see. Okay, wait, hold up. I'm just trying to look for a good question. Let's do... Do 17... Oh, no, that's too easy. Okay, let's work through 31. Number 31. Have you done 31?
The next permutation one?
Yeah. Or you already know how to do those or what?
I've never done this.
Okay, try it.
All right, you want to send me
Yeah,
the
I'm
link?
gonna hop on.
Okay.
Okay, let me invite you real quick. I'm gonna send it to you. Personal message. Oh shit, wrong thing. Give me a sec.
All right. So next permutation. I'm just gonna read this real quick.
Yeah, what are you thinking? I mean, you can read
So
it.
yeah, sorry, I was still reading. Uh, okay. So 321 does not have a lexicographical. Oh, so it's effectively like the next largest permutation. So it's like one permutation above in terms of making the integer that would result from this list. So for example, if we have
Swag demon. This is-
for example, we have 1, 2, 3, and the next one is going to be 1, 3, 2, and then 2, 1, 3. Is that? I think that's right. Right.
Yeah. So we just need to
Yeah.
return the next permutation, but the next larger one, but not too large. You see 1, 2, 3, and then
Yeah. It's going to be like it basically, if you took all of the permutations of this and sorted them in order, it would be the one next. I believe is how it works, right?
yeah.
Okay. I think I have an idea of what to do here. Just 1 second. I'm gonna just run this approach through my head real quick, and then I'll explain it to you.
Sounds good.
Just because I like I don't know, a lot of math things are harder for me to explain, if that makes sense. Just because like the way math works in my head is different than a lot of people. Okay. Yeah, so effectively what I'm thinking is I'm just going to I'm going to find which permutation is next. So I'm going to basically the permutations are going to be in a certain order, if that makes sense, no matter how you organize them. So what you need to find is find the index of like where you should pivot that to. For example, in this example, where we should pivot is going to be from 1, 2, 3. We're going to iterate. I believe we're going to iterate backwards through the list, and we're going to find the point where we should pivot. So here it's going to be.
Yeah, let's just work with one example real quick. This one. Because
Okay.
they're just going to pass you one at a time, right?
Yeah. So what we're going to do is we're just going to effectively go, and we're going to say where nums of I is less than nums of I plus 1. So obviously it can't be 3. So it's going to be 2 here because this is the first element. That's basically these two are ascending, right?
Yeah.
So once we have this element, we're going to find the smallest element that is larger than nums of I, and I in this case is going to be 2, so this is going to be our point that we're pivoting around. So the next element in this case is going to be 3. So in that case, we have 3 is our next largest element after 2, which is our pivot index. So then we're going to swap these two. So then we're going to have 1, 3, 2. And I believe in this case, this works fine. However, I'm just going to provide a larger number for an example. 3. I'm going to do this so that we have a different index. So for this example, our pivot index is going to be here because 3 is less than 4. So we're going to swap, and then the next largest index is going to be 4. So then we have 4, 3, 4. I'm not actually doing a good job of generating a test case, but effectively we need to reverse the subarray that comes after this. Just because, say we had 4, 5. Okay, here we go. Actually, we have 4, 5 over here. I'm trying. I don't think this example works either. I'm just gonna, because in this case this would be the pivot index, 4 would be, so that's why that's not working. But effectively, we need to reverse the subarray that comes after this in order for it to maintain lexicographical order. Does that solution make sense to you, or should I try to find the test case that I was thinking of? That
could you just walk me through what the algorithm would be again?
Yeah, sure. So we're finding we're going to iterate through the list in reverse order.
Sure.
Right. And we're going to find the first index I such that nums of I is less than nums of I plus 1. And in this case, it's 2. And then we're going to find the element after nums of I. Wait, no, not necessarily the first element. The rightmost element, I believe. Such.
So
you're
gonna sorry, I just want to clarify. So you're moving from right to left, and you're finding the first time that it's not where it breaks where it's not decreasing, or if it's increasing, or the first point where it's not decreasing.
Yeah, exactly. So in that case, we're going to find the first case where basically the two are ascending, and then that's going to be one of our indices that we're going to swap. And then we're going to find the next smallest element. So for 2, it's going to be 3. If the pivot index is 3, it's going to be 4. If it's 4, it's going to be 5. Does that make sense?
I see, yeah.
And then we're going to swap those two values.
Sure.
And we're also, in the case of tiebreakers, obviously we need to decide which one to pick. So we're going to decide, pick the rightmost, because the rightmost is going to be the one that will affect the least amount of bits. So we need to swap those two, and then we're going to reverse the subarray after the swapped element. Does that make sense to you?
Mm-hmm. So you're gonna reverse the back half?
Yeah, exactly.
Okay. And what's your rationale for that?
So the rationale is I'm gonna generate a test case. It's probably easier to 3, 2, 1, 2, 5. Okay. 3, 3, 3, 1, 2, 5, 5, 5, 6. Okay, so effectively in this case, the first time it's going to be non-descending.
Yep.
Okay, let me change this to a 4. Sorry. Is going to be here. So this is the first time. So our pivot index is going to be 2. So the next smallest element is going to be 3. So we're going to pick this 3 as our swap index. And then we're going to swap this 2 and this 3, right? So
We're gonna swap the 2 and the 3.
yeah, because the 3 is the next smallest element that's larger than 2.
Let's see. But if you throw the 2 in there, it's gonna decrease that value, isn't it?
Maybe my algorithm doesn't work then.
No, I think you're close. You're close. But
I feel like what I'm thinking, I'm just trying to, I think what I'm thinking might be slightly off. I think,
because you should try to avoid touching those most significant digits, right?
yeah, you're right. I think we need to only consider elements to the right of our pivot index for the, so in this case, the next smallest is going to be 4, right? Because we can only consider elements to the right. Yeah, that's right. Okay, yeah, that's my bad. I wasn't thinking. So in this case, we're going to swap 2 and 4. And in this case, the reason that we want to reverse the subarray is because 3314, 255 is obviously smaller than 552. And since we have our first increasing element right here that's been put to the end now, that is going to be this is the least significant bit, or I guess decimal. So we want to move this to the beginning here. So that way this is going in the most increasing manner that it can be.
Yeah.
Because since we started from the right, this is all going to be decreasing, or I guess non-increasing from this point, this 4
I see.
to the right. So that means this is all going in non-increasing order. So then we want to reverse it so that it's non-decreasing.
Yeah.
Does that make sense?
Yeah. Could you explain why we reverse it though?
Yeah, we want to reverse it because we want the next smallest number. So the next smallest number is going to have these decimal values increasing because it's going to be the smallest possible value that you can get, which is going to be, if you say, for example, you have 10 you have 10 numbers, right? Or I'm just going to use like 4 numbers. Say you have these numbers. The smallest number you can make with these 4 digits is going to be using the smallest number first, and then the next smallest, and then the next smallest, and then the next smallest.
Yeah. Okay.
So that's why we reverse it.
Yeah. Okay. Algorithm sounds good. So pretty much move from right to left while it's increasing. The first moment we see it drops. Right? The first moment we see it drops, who do we replace it with though? We need to replace it with the smallest number to our right.
Yeah, exactly. The smallest number to the right of the pivot index. I'm just calling it the pivot. Pivot's not really an accurate term. It's more like I don't know what the term would be. I don't think it has a technical term,
Yeah.
but in this case, I'm just gonna call it a pivot index.
That makes sense. So if you have a 1 here, are you gonna flip it? Are you gonna replace it with the 1?
So, is this saying this is the original?
That's
input?
the original, right? Yeah. So
Right,
you see a
right.
decrease. What are you gonna do there?
So in this case,
just clean
we're
this
going
up,
to
yeah.
see 2 and 5 are increasing. So here's our swap, and then the next largest. So it has to be an integer that's larger than 2 because it's has to be a larger number than the original.
Yep.
So the after swapping, it would be 5, 2, and we would want to use this 2 or this 5 realistically because we want to start from the right and go left.
Yep. Yep. Because we want to maintain that increasing order.
We want to maintain this decreasing order
I
exactly.
see.
And then we would reverse this subarray, so it would be 1, 2, 5.
Yeah, looks good. Let's try coding it up.
All right.
Yeah, good job figuring that out.
Yeah, that was trickier than I thought it was at first. N equals. I'm just gonna define these.
It's like super indented on my screen. I don't know if that's
Is it?
for me. I don't know. Maybe this thing's bugging out. Wait, let me refresh.
It looks normal for me.
Okay. Keep going.
Okay. I'm just gonna use a while loop. I think that's. Yeah. Okay. I'm going to in range. I guess I can just use n. So I'm going to start at n minus 1 because obviously we can't compare this value to I plus 1. And I'm going to go backwards through the list. And here, what I'm going to say is I'm going to say if nums of I is less than nums of I plus 1. I guess it would be, yeah, if nums of I is less than nums of I plus 1, then we want to break. Well, I guess we want to keep this n minus 2. So yeah, we want to keep this I value. We want to keep it stored in the list so we can use it later to know which index to swap. So I'm just going to say while I greater than or equal to 0 and I think this should work. We're just going to go down until this is not true, because then this means that nums of I is less than nums of I plus 1.
I see.
Because I just wanted to make sure we keep this I value, and if we use a for loop, it's just going to be it's going to be out of scope.
Yeah.
So I'm just going to say pivot equals I so that I can know, like, I'm just going to actually name this variable pivot because it's only used for this.
Mm.
And it'll be better naming. So what we want to do is effectively, if there is never a point where this array is increasing, the only thing we want to do is we just want to reverse the array, right?
Yeah.
Because say we have 2, 1. Okay, I'm just going to use a bigger number, 3, 2, 1.
Mm-hmm.
Then this is the largest that the value can be. And I believe the next permutation of this is going to just be the smallest. So we just want to reverse the subarray, like the entire array.
Yeah. Makes sense.
Yeah, so I'm going to say if pivot is, sorry, I accidentally muted on Discord. I pressed the wrong button. If pivot does not equal -1, so basically if pivot does equal -1, then that means that We went all the way through the list, and there was never a point where it was ascending, so we're just going to reverse the list at the end. And I'm just going to go ahead and do that at the end
Yep.
here. And do we want to modify this in place, right?
Which one?
Yeah, in place. I was seeing in the
Yeah.
problem it says we want to modify in place.
Uh-huh.
So nums. How can I do that in place in Python pretty easily? I think I can do something like this. I think I can do nums equal nums. Pivot. Yeah, so I can do 0 to pivot. Plus nums of I plus pivot.
This might not be in place. Let me see. So
I'm not sure if it is either.
yeah, okay.
I'm trying to.
Let's think about this part. How do we reverse a? How do we reverse an array?
Yeah, I'm trying to think of how to reverse a subarray. I know how to reverse like the whole array, but I'm trying to reverse just this, like the subarray past pivot. I'm gonna see if this is in place, and if it's not, I'll figure out how to do it.
It's not. Let's just implement a reverse function ourselves.
Okay, that's fair.
Yeah. Do you know how to do that?
Reverse subarray. Nums. Yeah. So should be something. I need more than that. I need pivot. But I feel like this is still not in place, though.
Is there a way we could do it with 2 pointers?
Yeah. That's what I was thinking. Yeah, that's fair.
Yeah, I think that's the only way to reverse.
LR equals pivot plus 1, then nums minus 1. So what we want to do here is we want to say while L less than or equal to R, nums of L, nums of R equals nums of R, nums of L. And then we want to say L plus equal 1, R minus equal 1. I guess I should do something like this actually, so that it's. I'm not gonna pass in nums actually. I'm just gonna pass in the pivot. That way, it's actually affecting this nums rather than some nums I'm passing in by reference or something like that. So I'm going to reverse subarray pivot, and then I don't think I return anything. Right, yeah, return none. So in this case where pivot does not equal does not equal -1, I'm going to say swap equals n -1. And then while nums of swap I think it should be less than or equal to nums of pivot. Yeah, so while this is true, we're going to say swap minus equal 1. So we found the first element that's larger than, in this case, we found the first element that's larger than our pivot index, right? So here it'd be 5. Right? Does that make sense?
Yeah.
What I'm doing here?
Uh-huh.
Okay. And then in this case, we're going to swap these as well. So num's a pivot. Num's swap equals num's a swap. Num's a pivot. And I think this might run. Okay.
You ran it? Let's see. What'd you get?
Yeah, it ran.
Nice.
Yeah,
Look at
that took longer than it should.
Nice. Okay.
I wasn't expecting that.
It's not the easiest question. Honestly.
I'm reading the chat now. You'd expect me to use XOR? You can't use XOR for that.
Let's see. How long did that take?
Can you use XOR?
40 or less? Oh, we should have put a timer.
Oh. We can run another one if you want.
Okay, flip it on me. Ask me one.
All right, let's see.
Because it's good to practice too when you do it both ways.
We got on
You
zero
got a good
track.
one? No, it doesn't have to be a 1-on-0 track.
Oh, okay.
Whatever, if you've done it before.
Have you done 289?
Check. Yeah.
Oh, you done that one?
Yeah.
Okay, let me find another one.
Marty's like, they need code forces for you, and I'll send you the link so we can collab on it.
I feel like the question took me too long. I'm not even gonna lie. It was because I was trying to explain it. Like if I were just coding that by myself, I could probably do that in like 5 minutes. But I was trying to explain it. I feel like that's like.
But yeah, that's
something
one
I'm
thing.
not super, especially with math problems. If someone asks me a math problem, it's so hard for me to explain the way my brain thinks about numbers.
No,
have you done 343?
That's the one thing that's probably my feedback would be integer break. Okay, let me try it out. Is this a math one or regular?
I don't know. I just saw it.
So given an integer n, break it into the sum of k positive integers. Break it into a sum of k positive integers where k is greater than 2. Here, I'm gonna send you a link into here.
I don't think this is a math problem. Yeah. Okay.
Come
You
on.
just made the link.
Send
I don't
you a
know how to
link.
make that.
Let me send it. You already see the solution, huh? Let's see.
No, I'm not looking, but I don't think it's a math problem.
Paul just got a offer, but this guy's trying to double the double comp. He doubled his comp and double
You gotta
again.
double your comp. You always gotta double your comp.
Okay, let's see. You're given an integer n. Break it into the sum of k positive integers, where k is greater than 2, and maximize the product of those integers. Return the maximum product you can get. So n, we're given n is equal to 2. The output is 1. So 1 plus 1. So you can break it up into these digits, and essentially. So break it up into k positive integers where k is greater than 2 and maximum. It's a bit of a math question, I feel. Let me see.
Let me look at the solution and see if what I'm thinking is wrong.
Okay, wait. Let's walk through this test case.
Yeah, I guess you can do math, but the optimal solution is not math. Well, the optimal solution is math, but there's a non-math solution that I would think is fair for an interview. I don't think.
Where's
I
Super
don't
Cracked? Oh wait, hold up. Super Cracked said he wanted to run a mock. My bad. I forgot Super Cracked
okay.
needed a mock. Super Cracked, hop on the lounge, because this guy said he needed to sleep, and all of a sudden, and then there's a quant guy in here. Okay, hop in.
Okay, you want me to hop out?
Wait, just wait till he hops. And yeah, we'll run one again at a different time. That was
Yeah.
good. That was fun.
All right.
Yeah.
Yeah.
Thanks, Paul. Yo, V-Dog, what's good?
Not much.
Okay.
How are you?
I'm good. All right, Jalen, you're next. Cool. How many questions have you done?
210.
Around 210. So how are you feeling about it? Like, Are you pretty comfortable?
I feel like I'm pretty strong, but it really depends. Like if I see a problem that's similar to one I've solved before, then I'm really good at like, pattern matching or whatever.
Yeah.
But if it's something I've never seen at all before, it really just depends. I feel like my problem solving skills are pretty solid, but I wouldn't say I'm insane or anything.
I see. I see. So, okay. Let's do. Do you like the ones where you just code, or you like the ones that are? You like the ones where you just code, or you like the tricky ones?
Like as in problem solving a lot.
Yeah.
Either works, to be honest. I have a few interviews coming up, so just any like interview practice is good.
Okay. Let's run. Let's run this one right here. Oh no, this is blocked. Wait, see. Let me look through my questions. Give me a sec.
Okay.
Shit, I need to. You got a bunch of interviews coming up?
Yeah, well, I'm in two interview processes right now, and
Nice.
then I passed resume screens for a few companies and got OAs and
Nice.
aced the OAs, so I'm expecting to hear back from them as well.
Okay. Have you done basic calculator before?
The problem doesn't ring a bell. Let me check
Alright.
though.
Try look up 227.
Okay. I have not.
Okay, let's see. Wait. Let's see a couple. Okay, let's warm you up real quick. Listen. Have you done 543?
5, 4, 3. Yeah.
Okay. Wait. Have you done? Let me see. Can you do hards or not?
I mean, it'll probably take quite a bit, but potentially. It really depends.
Have you done 695?
Yeah, I did it last night because you told me.
Oh, really?
Oh, wait, no. There's a different one I'm thinking of. Oh, no, I was saying this was largest island. Max area of island.
Oh, you tried the largest island? You got that
Yeah.
working?
It was hard, but yeah.
Nice. Good job.
I got it working after like an hour and reading through the solutions.
No, that's
but
good though. You still got it working. That's still
Mm.
still good. Okay.
I've also done this as well, though,
Okay.
because it's just a number of islands, but
Have you done? Have you done 921?
minimum to add to make parentheses valid. No, I haven't.
All right, try that one. Wait, let me invite you.
Okay.
Wait, I'm gonna send you an invite on Discord.
Okay.
Okay, I sent it to you. Wait. That's not the one. Oh yeah.
On Discord? I don't see anything.
Wait, I need to add you as a friend real quick. Okay, I added you.
Oh, okay. Okay, I accepted you.
Okay, sent it.
Okay. Parentheses string is valid. Yeah. String. Okay, so immediately I'm thinking that we just use a stack and output how many brackets are left, but I think there's a bit more to it, probably. I can't use a stack because these aren't valid. These are invalid. We could. Was it only? Oh, it's only this type of bracket, the normal curly one.
Yeah.
So yeah, we just have to make sure that they're in order as well. In the string as we can insert C's at any portion of the string. For example, insert parentheses, closing parentheses. So okay, so I think we can iterate over the string, increasing it for every open one, and then decreasing it for every closing one, and something like that. And but if we don't have any open ones yet, yeah, so like you can see like the code editor too, right?
Yeah,
Like
I
if
can see.
type
You're gonna switch to C++?
Yeah. One thing is we have this answer thing, and then we go. Yes. Close count. So I'm thinking that we keep track of these counts. Anytime we encounter a closed bracket and the open count is 0, then we add one to answer. And then anytime we encounter, and I think we just need this actually, these two. I think, yeah, so if we encounter a closed one and open count is greater than 0, we just decrement the count. And if we encounter closed bracket and open count is 0, we add one to answer. And after we loop through all of this, we add open count to answer as well. And I believe that should be fine if I'm interpreting the question right.
Mm-hmm. Sadvik is asking why.
Why what?
Oh, never mind. I think he's talking to someone else. Okay, so if it's opening, you increase the opening. What happens? Okay, keep going.
Open count. So basically, we just go through the string. If we encounter an open bracket, we do that. No, we need. It should be different. So yeah. And then else if this. Change this actually. If open count. So if we have brackets to match it with, we'll match it and we'll just decrement the current open count. But if we don't have any open brackets to match it with, then we'll need to insert a bracket so we increment our answer. And then at the end, any open brackets that we're left with that weren't matched, we will also need to insert some to match it with. So I believe this would be the correct answer. Let's see. If we go through this test case, so the first test case is an open bracket, so open counts 1. Then the next one, it would cancel, and then we'd have a closed bracket, so we'd add to 1. And then,
I see.
Yeah.
Yeah. Okay. Sounds good. Yeah. Let's just run it. We're just warming you up. Okay. Nice. Have you done 863?
60.
Or let's do.
All nodes A distance and binary tree. I don't think so. Let me check. No, I don't have any submissions.
Let's see. Okay, try that one out. I'll send you the link.
Okay.
Paul, I don't know why it's there's some mediums that are just not that hard. Paul's asking why it's a medium, but I think
Yeah,
it's still a medium.
probably
'cause
shouldn't
you-
have been.
I think it's still a medium because you still, if you've never worked with validating parentheses before, sometimes it's not that easy to see that you could use a stack to solve it, right? I don't know.
I mean, you didn't even need to use a stack though. Like
Yeah.
the solution we came up with was O of n, O of 1.
Yeah, it's true. Yeah, I don't know. Okay, I'm gonna send you.
Yeah, it's fair. I guess you can't immediately know that you can just do it with the count instead of the stack. But if you run through like a few of the test cases, you'll realize you're only using the open count.
Yeah.
Like that's where you're only thing using the stack to keep track of.
Here, did you join the
that
link I sent
thing.
you?
Yeah, just join. Okay, I think I did at least. I don't know.
Or join the very bottom one.
I think I did, but it doesn't look like it's a shared room.
Wait, let me
It looks
see.
like it's just the actual problem. Like,
Okay.
how do I check it?
Try it again.
Okay. Given the root, okay, yeah, no, it's so given the root of a binary tree, the value of the target node, target, and integer k, turn an array of the values of all nodes of a distance k from the target node. Okay. That's interesting. So, how do we do this? We would find the target node,
Yeah. Wait, I'm grabbing water.
and then,
Just keep talking.
yeah, so we find the target node, and then from there, we would continue our traversal. So we get the ones below, we just continue our traversal downwards. But to get this one on the other side of the tree, what do we need to do? I guess we would. Okay, in order traversal.
Don't read the chat though. You don't wanna. They might be giving a hint.
I'm not.
Yeah.
Okay, in order
Keep working.
traversal. And then 2 away. So
Paul, what was that question you sent me? I'll read it on the side. So you're gonna do in order traversal to get what?
find target.
Okay, you just
And
want to
then-
do DFS to get the target kind of thing.
Yeah, and then once we find the target, we will. Yeah, we can BFS. Or honestly, we could DFS and just pass down a level. DFS, same side. Really, the issue of getting this one on the other side, like you see this one. What I'm thinking is maybe. Okay. 2 away. So it's distance k away. It's not even levels k away. It's distance k. So, what is that the same as levels? Or it could either be, yeah, they could either be 2 levels below, 2 levels above, or yeah, like the difference from the root then to the other side. So if we find our target, we continue downwards to get those ones. I don't know if I want to split this up though. Like, let's say we do a BFS. We find 5. We identify it's on level 1. Then we know what we're looking for. We're looking for all nodes that are level 3 on the left, and all nodes that are level 1 on the right. Which, actually, maybe that's what we should do. Yeah, maybe that is what we should do.
What are you thinking? Sorry, can you repeat that?
Yeah, sorry. Okay, BFS, find target and its level, and then we know what we're searching for. So let's say we find 5, like in this example, one on the left, and it's level 1, and then we know K is 2. Then we can identify that on the same side as target, it's K level below and K levels above if K less than level target, K equal level of target, then root if K greater than level of target, then K minus level on other side from target. That would be all the nodes we would have to return, I believe. So in this case, BFS get 5 and level 1. And then we know that on the same side, 2 K levels below, so level 3 on the same side. And we check, is K less than level target? It's not. 2 is greater than 1. Is K equal to 1? It's not. Is K greater than 1? It is. So then K minus level on other side. So we know we have to return level 1 on the other side of the tree. And then...
Yeah, I think that... Yeah.
And then, yeah, I guess for obtaining these nodes, we can just BFS, keep track of levels by a vector where vector I equals level I from left. Oh, but
See if that would work. What if we're the root? We're just like 3. I mean, yeah, that would.
Yeah, if it's the root, then yeah, we could just the whole level. Okay, if we have the whole level here, how do we identify what's on the right and what's on the left? Do we just do it separately? Maybe.
So taking a step back, is there an easier way to do it? You think?
Is there? Root of a binary tree. Target and an integer k. Return an array of all values of distance k. Like, you mean just like DFS and pass down instead?
Because the problem is when you're trying to do it in one pass, or I mean, you grab the root and you're trying to find the level, and you're gonna see on the right side, look for the one that's.
Mm-hmm.
Yeah, but how do you know it's looking at the right side? Pretend we extended this. There was more nodes there. For example, take 3 and just add a bunch. 3 and add a bunch of parents to 3.
A bunch of children to 3?
Or
what do you mean?
Like pretend 3 had more parents, or 3 had like 3 parent, or there's 3 is not
like
the root.
3 wasn't the root?
If 3 wasn't the root, right? So how do you know where to look from there? Like how do you know where to get to the right side? It might work if with this case where you have the root, right?
Yeah. Yeah, so maybe we just treat the parent of the target as the root. No, because yeah, because if like 6 was our target and K was 2, we couldn't treat 5 as the parent or as the root because we would need to return a 3. What is this? Even the root of a binary tree.
Well, okay, let's think about it. What if we? I mean, it's only complicated because it's a tree, right?
Yeah.
Right, Q. What's good? If it was a graph, would it be just as hard?
No. But because we could, well, if it was like an undirected graph, then no, because we could just traverse like outwards from 5.
And then what would you do? How would we get all the ones that are K?
If this was an undirected graph, I would just BFS from 5 and take everything that was on like our second iteration.
Mm-hmm.
Can we do that though? Like, because I can't go from 5 to 3.
Yeah. How would you? Is there a way that you can get it like converted to a graph?
Like, make an adjacency list?
Well, okay, for 3, I mean, you have all the pointers going one way. I think if you just stored the parents, you'd be able to figure out, like, you'd have a full graph there.
I'm not sure I understand.
Are you watching my stream?
No.
Okay, hop on the stream quick.
Okay.
I'll diagram it for you. So right now we have this binary tree. And these are pointing this way. Right?
Yeah, exactly.
So you essentially, you have what you need there, right? So for every node, when you're doing a DFS, if you just keep track of its parents, you turn it into a full DAG. Or not a DAG, sorry. It becomes an undirected graph. And now it becomes just a graph problem, right? So I would suggest trying
Track
it
this
that way.
parent out, like with the
You can create a set, be like,
a map, set, yeah.
yeah, something like node and
Mm.
the parent, where it's a reference.
Yeah. Okay. So let's see. If we traverse the tree, and for each node, we keep track of its parent so that we can also iterate back to it. So then the 3 connections for each node would be the 2 children and the parents.
Yeah,
Yeah.
you know when we do a regular BFS, right? We try to look for the neighbors. So for
Yeah.
this one, just look at its left and right, and then look in the parent map, kind of thing.
Mm-hmm. So, okay, how are we gonna make this map? Let's think. Just just while we do the traversal. Okay, so BFS, but a map and and E equal so if we did like there's something, then we have our DFS. Do we do this separately though, or do we do this when we find? 5. I guess we could build this up as we go down to 5, right? I don't see why not.
So you're just wondering, should I do this in one pass or should I do this in two passes, huh?
I'm
What would
thinking.
be, how would that affect the runtime complexity in theory?
So go down to target, and then we have the map built, and then we BFS out, and that would be like, let's just say OVen for finding because it's a binary tree, and then the BFS. So for each one there's 2, and there's K levels, so it'd be like, what is that like? I guess 3. So,
but it's worse. K can be any
3K.
value, right?
Yeah. So I think it would be like ON plus K if we did that, and then if we didn't do it and we redid it, like.
Or do you mean it's going to be OVen plus OVen? OVen for the DF.
OVen plus K. So OVen for finding the target, and then O of K for like the BFS outwards from the target.
Let's see what K is. Number of nodes. Let's see. Yeah, I mean, I would say just do it in 2 passes because it doesn't really affect the complexity. Theoretically.
Yes.
And yeah, I'm not sure if you could even do it in 2 passes. Or 1 pass, sorry.
Okay, let's just do this in build path. I'm going to make this build path function at the top here. So, void build path. What are we taking in? A root. Node T and app. Node.
Yeah. What I'll say, because chat's asking.
Asking what?
Or basically, because I see a lot of candidates do this too when I interview. They have a 2 pass solution and they think it's suboptimal, but usually O of n plus O of n equals O of 2n, and then you drop the constant, right? So in theory, it's not that, like, theoretically it's the same runtime. Right?
Yeah, I mean, I guess it depends on the algorithm though. Like on some of them, like KMP, like O of m plus n, they treat it differently than like O of n. Or like, DFS on a graph is O of v plus e. Like, a lot of them keep the pluses in even though it's asymptotic.
Well, v plus e for BFS, the number of edges could be different, right? So pretend I have a graph and they're all just connected to each other. Like the number of edges matters there. Because we have to traverse a ton of edges. But if for O of 2n, we could pretty much drop it to just O of n. Like drop the constant.
Yeah, that's fair.
Because I've never been in an interview where I did it 2 passes and they said just do it in 1 pass. Especially if it didn't really affect the runtime. And even when I run interviews, if someone's trying to over optimize it, try to do it in 1 pass and 2 passes, when it doesn't really affect the algorithmic complexity in theory, then it just, like, I'd rather them not do it. If that makes sense.
Yeah, that makes sense.
Because, yeah, sometimes I feel like I've seen candidates make that mistake too much where they calculate the runtime complexity wrong, so they think that they need to optimize it, but they don't need to, and then they end up pretty much going in circles or pretty much convincing themselves that they don't have the right answer yet.
HT on the left. Yeah. Yeah, I think we have our path built now.
Okay, we're doing column recursively built path. What's path here?
Yeah. It's just the map. It maps
I see. Okay,
the child to the parent.
I see. Okay.
And then now that we have path, we still need to. What do we need to do? We still need to go down, and so we still need to find value, and then BFS out from value with our path and children, I believe. Yeah. I'm gonna say so tree node. What are we gonna call this? Call this V. Guarantees find value root target. So if E equal to V return C oh yeah, so
Let me follow you on there.
find value root target. So if it is value, we return it, but if it's not, then we need to should do if T, if not T, wait, how do I return this properly? So if it's not T,
What are you thinking?
okay, I'm thinking, so obviously if T-val matches V, we just return T, like that's the correct one.
Yeah.
I'm thinking if it's not, obviously we need to continue our traversal, but I'm thinking how do I like make this return like call stack match up properly? Do you know what I mean?
Wait.
Like, do I do return find value to the left? Well, what if it's also not on the left? That's the kind of thing I'm thinking. Right. I don't, does that make sense? Do you understand what I'm saying or no?
Wait. Okay, we're finding the value, right?
Mm-hmm.
So you just want to return that value when you find it?
I think we want to return the node object, right?
Yeah. That makes sense. Because then you want to perform a breadth first search on top of it?
Yeah, but I'm saying if the node we're on isn't it, so like let's say we're on 3, obviously 3 isn't it, we have to continue downwards, right?
Yeah.
But like what should my return statement be here? Should it be like,
If the value
obviously I know I have to call find value on both of them,
Yeah.
but to make my return statements line up, I'm not sure what to do
Okay,
here.
try it. I'll pseudocode something. Be like, if none, return none. Essentially. and then call left and right. Or I mean, call this one, right? If you see the value, return it. Otherwise, call left and right, and then return one of them. Return either of them. I mean, one of them has to be it then, huh? Right? Wait, let's see.
Yeah, well, yeah, like one of them has to be it, but I'm saying, what do I return when it's
Be
not?
like if left, return left. If right, return right. Otherwise, yeah, return left or right. Essentially, whatever one's not null.
Mm-hmm. Okay, yeah. So if not t, return null pointer. If t, return that, and then yeah. So we'll just return a null value. It's not it. Yeah, and then okay, yeah. So if t dot left, if t dot left, find value t dot left, e.
Yeah, just keep coding. Give me 2 seconds. 2 seconds.
Alright.
Be right back. Keep coding.
If t dot right, find value t dot right, v. Not t, return null pointer. If t equals return t. Then we get right and left, and then we return whichever one of them isn't null, or if they're both null, then that's also fine. And then yeah, okay. So we should have our thing here, and then we'll BFS out from it.
Nice.
So what are we returning again here?
We're gonna return a list of all the nodes.
Okay.
Essentially, you'll see the.
So, yeah. So you need to return vector int. So vector int. So yeah, we'll just BFS outwards from this, treating the possible, yeah, like the connections as parent and the two children. So BFS, and what we're gonna need to pass in is the, what did we call it? Path. We're gonna need to pass in path. And then what else are we gonna need to pass in? Are we gonna need to pass in anything else? Oh yeah, the start pointer. Start. So is it anything cool? BFS path E. Okay, and then this BFS is just Q, Q, and then we will push our start node into the queue. So Q push start, and then while Q dot size greater than 0, need int dist. Oh, we need to pass in k as well. Okay, so int distance, so initial start at 0, and then every time we get back to the start thing, we have to get the current size. Is that correct? Yeah, the size. I think it says after we pop it. So we node sc chmod view is going to equal to q dot top, q dot pop, and then int s equals q dot size, or I equals 0, I less than s, plus I. We are going to need to we're going to need to visit each of these. So actually, I think we should track or perform this visit first before entering the loop, probably. So so if u dot left, u dot push, u dot left, if u dot right, u dot right, then
Using a queue.
u dot push path at u, so that'll push in the parent, and then and then just repeat this for everything else in the level, I believe. We should probably rename this here, be like V or something. Okay. Let's see. What we can do is we'll keep the size greater than 0, and then dist less than k. So let's think. We'll push everything that's 1 away and increment it to 1. Then we'll push everything that's 2 away, increment it to 2. So once it's equal to k, we can break the loop and then just push everything into our answer that's left in the queue, I believe. That makes sense to me, yeah. We push everything that's left, because that would be everything that's on that level. Well, queue to size greater than 0. Let's unload this queue. Node view top dot pop, and then back, returning the values, so it would be val. Okay, let's see. So we create our queue, push in the start node, and initially we're at distance 0 from the start node. Queue to size, so we pop this pop node. We get the size of the current queue so that we make sure we handle just the ones in this level while we're tracking it to be this level. Then we push anything that's not null, which should be parents. Wait. Okay, but what if we get to the root? We can't access. We're gonna need to check if path u. Because if we're at the node, then that would be one that wouldn't have a parent. So not at the node. If we're push path U. Handle everything on this level, so we pop it and push every necessary. I should add the same check here as well, though.
Compiler.
Yeah, where did I not match something? Expected where line 10. Alright, true path. Right. Yeah. B. I'm not sure where this missing. Oh. Unidentified. Oh. Okay. Tree node. Or.
Okay, we're doing a BFS. We're passing the path.
What? Move our conversion from.
What is this? If. Do we need this right here?
I think so, because like for the very first node, actually I guess if we move the pop to after we get the size, then we wouldn't need that, right? Or wait, no.
Or let's just remove this in general. Or this part.
Well, we needed to push the stuff from the very first thing we pop at each level, do we not?
Let's see. So we start with the Q, right? And we push the first one to, and we say this one's a different distance, right? Okay, what if we do, while the Q size is this, or sorry, right? Just that. So we grab the size of the Q, which is the just one element, and we pop out all of its neighbors. And we pop those into the Q. Now the Q has a size 3 or a 2. Then we do it again. Right?
Getting a compiler, but I'm not sure how to fix that, to be honest. I've never ran into that before.
Yeah, I don't know. I mean, you're close.
I think the solution is correct, but yeah, the compile errors are kind of holding it
There's
back.
probably just compiler error.
Yeah, I would have never guessed we had to turn this into a graph, to be honest. I don't think I would have gone there on my own.
I see. What were you? Oh, you were thinking just DFS it one time? Let's see. What
Yeah, I was kind of thinking we would have to do some. I don't even know exactly what conclusion I would came to if I just worked on my own for like 45 minutes and like no help or anything.
Yeah.
Well, originally what I was thinking was kind of like we had like a global variable or something. I don't know. Actually, no. Yeah, I don't know. I don't have no clue what I would have come up with. I
Yeah.
don't think I would have been able to solve this on my own. I don't think I would have been able to decide we should turn it into a graph.
Yeah, with a lot of different questions, sometimes I look at it, I'll be like, is there a way to turn it into a, or you might have to look at it a few different ways, like, cause yeah, you
Hmm.
looked at it, and I remember when I first did it, I looked at it, the first thing I was thinking is when it's saying K, right? I'm like, okay,
Hmm.
if it would be nice if I could just BFS from that specific node
Yeah,
to
that's
get the
exactly what I was
fit.
thinking. But the idea of turning into a graph, I've never run into that concept before. I've never done a question before where I had to turn a tree into a graph. So I guess, yeah, now that I have that concept in mind,
Yeah.
hopefully it'll be
Good.
easier to
Yeah,
recognize it
good
in the
try.
future.
Yeah. Well, have you done a lot of BFS questions? I mean, you have sort of the algorithm. It just was a bit buggy.
Yeah, I've done my fair share of like BFS and DFS. I think like I could implement them.
Yeah. The main thing that I would do is the just work on implementing them super fast because a lot of the interviews you should be able to implement them in like 10 minutes or something. As soon as you find out, just like
Mhm.
implement it. Yeah. Because if
Well,
it
DFS I can do super quickly. BFS probably need a bit of practice. Oh,
yeah
okay. I see how you rearranged it now. This makes a lot more sense.
yeah practice some more BFS. Because
Mhm.
when they start asking you BFS with slight variations, it's like if you had to do a Dijkstra's or something.
I can do Dijkstra's.
Cool. I'm gonna get this Jalen guy to hop on. Keep it
But
up. What time is it where you're at?
dude, it's 148.
Oh damn. Thanks for taking the time out to jump on an interview, though.
Oh yeah, of course.
Yeah,
Always looking for some practice.
cause you
Thank you
got
so
practice
much.
coming up soon too, right? You got something?
Yeah, yeah. I have a few final round interviews coming up the next few weeks for pretty decently
I
sized
see.
companies,
Okay.
and then I aced the Amazon and TikTok and Capital One aways last week, and I'm
Nice.
expecting to hear back from them as
Okay,
well,
sick.
but we'll see.
All right. Hit me up if you want to do more practice.
I will for sure.
All
Thank you
right.
so much,
No
man.
problem, man. Have a good night.
You as well.
Jalen, hop on the chat.
Hello, hello.
Yo, it's good.
Yo, okay. All right, James. I've been watching your videos for a bit. I have this interview on Wednesday. I'm like, oh my god. I don't know how I made it to round 3 of this quant firm.
Yeah.
It's for like a Python software engineer position.
Yeah.
And so far they've asked me like kind of easy questions. So on the OA, they asked me like something related to counting anagrams,
I see.
and then hang on, let me see. There's like some audio issues. 1 second.
Yeah, no problem. Take your time.
Okay. Yeah, you were a little quiet. So,
How do I sound now? Chat, I sound good or what? Just need to
good.
make
No,
sure.
you're quiet for me. Like on in the Discord chat on the streamer, fine.
All right. Cool. Okay, what was the
Okay.
second? You did
I don't know.
you did a phone screen and now you're on the onsite, huh?
No, I think this is phone screen number 2.
Okay.
And then the onsite, I don't know. I'm like scared to ask them. That's another thing. These people are like really scary. So, like, in my first technical phone screen,
Yeah.
they just asked me like a design question, like to design like a class, and then they quiz me on what's it called? Time complexities on stuff like hashing and popping from a list, stuff like that. And then, yeah, I have this next one on Wednesday. I think they're going to up the ante a little bit. They seem to like word problems,
I see.
and they focus a lot about if you know Python under the hood, I think. And yeah, also this takes place on a hacker rank. So I think it's going to be like another Python tech interview, basically,
see.
like question number 2.
Okay. So how familiar are you with lead code?
Yeah, I've done it like now and then for a little bit, but I definitely not like I'm super rusty. I don't have any of the very many problems, and if I do, it takes me kind of a lot to like think through it. I've been like doing as much as I can, just like trying to cram everything because this interview fell into my lap, and I just been like zero preparation at all until very recently.
Yeah, so you're a bit nervous for it then, huh?
Yeah,
Sound a bit nervous.
yeah. I'm nervous. I'm also nervous right now. I mean, that's good because like there's no other place where you can have an experience like this. So
Yeah.
I mean, thank you so much for doing the stream and everything. Like when I practicing while nervous is probably the most valuable for me.
Yeah, that's perfect. Okay. Let me start off then with an easy question to warm you up.
Okay.
And then from there we'll move it up a bit.
Okay.
All right. Okay, we're gonna have you done question 408? Oh shit.
Okay.
This is-
What's an easy way to look at problems by
you
number?
just
Because
hop
in the
on
URL
LeetCode, hop on LeetCode by the problem. Just go on the problems and search it.
401, you said?
Oh no, sorry. That one's we can't use that. Wait, let me look through my questions. One sec. Chat, who got a nice easy one? At the same time, I'm gonna look for one. You think they're gonna ask a lot of tree questions, or they ask more math questions at the quant fund?
I think it's pretty far from the quant side, so they could ask me anything honestly. Maybe like more likely tree or graph.
I see.
Probably not math. Maybe a little bit of math.
Alright. Okay,
I don't know much. This is a very small company. There's no information about them online, and no one I know has ever heard.
How'd you get reached out to them then?
I cold applied because like the city I'm in, there's not a lot of big tech, not a lot of like thing. I mean there is, but like I'm in Chicago, they like each of the I think Google has like a really small office in here. They don't really hire devs or anything. And then that's pretty much it. Everything else is gonna be in like the financial services space.
I see. Trying to find a good question. Hold up.
I also did another company where I made it to the end and they ended up that was like the on-site. It had like a bunch of technical questions and I did not pass that one. I think they asked me easy questions, but I don't think I was good at communicating.
I see. Okay, let's work through this one question. I'm gonna send you a link. And we'll run it like a regular interview.
Okay.
I'm gonna send you a link real quick. Okay, I sent you a link. Oh, sorry, that's not the right one. I sent you another. Oh wait, yeah, I sent you another one.
Okay. Where'd you send it?
In Discord.
Oh. Okay, the second link, right?
Yeah.
Okay. Okay. All right. So is it working?
Yeah.
Okay. All right. Let me read the question. Goat Latin. You're given a string sentence that consists of words separated by spaces. If a word begins with a vowel, append ma to the end of the word. Apple becomes apple ma. If a word begins a consonant, remove. Okay, so this is kind of exactly like Pig Latin, except different letters. So it sounds like we just have like a bunch of if statements. Add one letter to the end of each word per its word index in the sentence starting with 1. So the first word gets a added to the end. Second word, oh, that's funny. Okay, oh, that's so funny. I speak goat Latin. I'm peaks ma oats gama Latin. Okay, there's some things that okay. So we're gonna want to check these rules pretty much in this order exactly because we first we don't want to find out if it begins with a vowel and a consonant, and then we're going to append it to the end. And then after that, we have to add a bunch of A's on top of that. So we're going to want to do this part first. And this is just going to be simply like if it's one of these letters, append ma to the end of the word. If it begins with the consonant, remove the, just do exactly what it says. And then at the end, we're going to pad it with a bunch of A's. So we're going to have to keep track of these indices. So I'll have like some kind of variable I for index of word. There's going to be a big for loop through each word. And then, we'll just have like if statement for consonant or vowel. And then second, then we add A's to word. And then once we have all the words, we just return the sentence. I'm trying to decide if I want to split these by space. Is that a good idea? I'm thinking about that now. Probably. It can't hurt because I can always join it at the end before returning. So like I would do like space.
Let me ask you one quick Python question, just because they asked
Sure.
you the internals of Python, right?
Yeah.
What's the runtime complexity of something like that?
Okay, so in this instance, both strings would kind of act like a list. So we are appending essentially a new element to a list here, and in Python that is constant time.
Okay, it's actually this would actually be O of n time to do
Oh,
this.
really?
Yeah.
Ooh, okay, wait, pause. I actually didn't know this. I need to. Why is that? Is it because we have to?
Because strings are immutable in Python, and most languages I think they're immutable.
Oh, sweet. Oh,
You know
that's.
what I mean by that?
Yeah. So we're actually just creating a new string and then copying all the letters one by one over.
Yeah.
Okay.
So a lot of candidates can end up try to do this, and it ends up making their algorithm super slow. That's
Let
one
me-
thing, yeah.
Okay. So this hint that you've given me, I think this is I think you're
But I was just testing some simple.
okay. Well, let's see. It affects this part of the algorithm. My plan was to just append a bunch of A's to the word until we get to I, right? So if we do this, it's O of n for each word. That could be very bad. Maybe I would need to figure out a better solution for these A's.
So I for index. Okay. Walk me through your solution though. You're gonna split it by spaces here, you said?
Yeah, first thing I'm gonna do is so I can iterate through the sentence, just split it by spaces.
Okay, let's I'm down here. I'm gonna so you're gonna get it into something like I speak go Latin,
Yeah.
right? Okay.
Yeah.
And then what?
Okay. And then okay, so
Like,
let's say that we have
in your
I.
interviewer also too, it's good to write down some things that you're thinking. Otherwise, because when you just say it out loud, I don't exactly know what you're saying.
Mhm.
I'm able to because I run a lot of these, but some people might not know might not understand you at all.
Okay. All right. Yes. Okay. um so okay, so from here we can uh do like something like for each word in this list, and then we just take a look at the first char in whatever word. So if we have so we have so this is so we have a for loop here. We start with I, right? We take I and then we look at the first char, which is I. And if it is and then we do like a different behavior for vowel or a consonant. So in this case it's a vowel, so we just append ma at the end of the word. Okay. So we're actually this is also like linear time. If a word begins with a consonant, remove the first letter and append it to the end. So let's say this wasn't I. Let's say this was like maybe, I don't know, J. So we would do J plus remove. Well, okay, I'm removing J. I'm appending it to the end. So because this is like a single char, this is kind of a no-op. But we're appending ma at the end of that. And then after that, because this is index 0, we don't append any A's, but regularly we would just do as many as like times whatever I. So we do the letter A times I, we put it to the end, MA, and then J. This is so I don't want to append the A's one at a time here. I need to have all the A's ready to go.
Okay, so we're looking at
That way,
okay, let's see. We're looking at A, so we split it here. So let's do it even just the most brute force ever. So we see an A, and what are we gonna do here?
so if we see a I,
Yeah.
okay, we're gonna if we see an I, we find out what letter it begins with. So the first letter is I.
Sure.
Yes.
Yep.
I is consonant or vowel? Or vowel. So I is a vowel
Yep.
if I is in A, E, I, O, U, right?
Exactly.
Okay. And if that happens, we need to add MA to the end. So I plus MA. Then we have like our index I. So index I is 0 because this is the first word. And then we will have like and then we'll have the letter A repeated I times. and then we will want to add that in here.
Oh, lead code hard in the building. This is the real one. This is the real lead code hard. Lead code hard. We have Jalen here who's interviewing for a quant fund. That's you're based in the East Coast, right?
Chicago.
Oh yeah, Chicago.
Yeah, it's yeah, they usually so far my experiences, they give me what looks like an easy question, something like this. And then they actually like go really deep into it.
Yeah. Okay, let's get this implemented. I think just start writing some code. Let's see. I think what you were doing there.
Okay. Yeah, so for word and sentence. Oh, actually we need that's right, we need the index. So for I in we also need the word. So in Python we can do for I comma word in enumerate sentence.
Sure.
Oh, sorry. Sentence. So actually, words equals sentence dot splits by a space. So this gives us a list. Okay. Right. So then, for I comma word and enumerate. So the first char of the word, we're gonna want that. So first char equals word of word 0. Wait, is there a case if I have 2 spaces in the sentence that could totally? So, yeah, all the words in sentence are separated by a single space according to the constraints. So I don't have to worry about that. So if first char is a vowel, A, E, I, O, U, vowel. This is going to, we're going to want to append MA. So okay, I'm going to go back a little bit. I'm going to try first, just like having to try to reduce the amount of string appendings I'm doing. I'll just have like an empty string here. Well, what's going to start as an empty list, an empty string. I'll just have an empty string here, and then whatever comes out of the logic related to appending ma and then appending the letter a bunch of times, I'm just gonna put all of that in here, and then at the end we'll do that big operation at once to try to reduce the number of times we're doing that. So okay, so if first char is a vowel, then to append equals MA, else it's a consonant. If it's a consonant, let's see. Remove the first letter and append it to the end, then add MA. Okay. So okay, I need to remove the first char. I'm going to be really careful with how I do that.
I mean, let's just do brute force for now, and we could talk about that and follow up.
Yeah, sure. Okay, so yeah, so word equals, I'm not sure if I'm allowed to change it like this, but I was gonna something to this effect. I don't think I'm allowed to edit this though. So, okay, I'll just go with this for now. To append equals first char dot mod. Okay, we're good. We're good. And then to append plus equals and then the letter A. Times index. Okay, I'm actually not sure if I'm allowed to do this, because I know it works for lists. So to be safe, I can. Oof. Okay. Okay, we're done with to append. So then, so results is equal to word plus to append, and then okay. So our resulting word is the original word plus whatever we're appending here. So this is going to be MAAAA. Result sentence, we have like a list here. That's going to store our result words, because I'm not sure if editing this is a good idea. So we can result sentence dot append result word, and then here we return space dot join results sentence. Let me just make sure I haven't missed any requirements. Big for loop. Okay. Vowel, consonant. Okay, we actually start with 1 here, so I'm glad I checked that. So this has to be I plus 1.
I see. So we're looking through the words. You don't, honestly, in most interviews, you don't really need to type it. But let's use you're splitting.
Yeah, okay. This seems reasonable to me. Let me. Okay, I said I wasn't editing Word, so I'll just do like. I'll just do result word is a pointer to Word, and then we'll just do. Okay, this is a mess. I know, but it's a working solution, and then I can work incrementally from here. Okay.
Okay, walk me through your code. Let's see. Okay, you ran it, and what'd you get?
Oh, sorry. Was I not supposed to run it?
Oh no, you could run it all you want. Let's move this all the way up to the front top though. You were a bit further on.
Okay. So to walk you through my code, so first we're going to turn our sentence into a list so that we can iterate through our words. Okay, I actually just caught a mistake there. So we're going through each word in words. First thing we'll do is going to look at the first character, if it's a vowel or a consonant. So if it's a vowel, we're going to append ma. And then if it's a consonant, we're going to remove the first character and then append first char plus ma. And then after that, no matter unrelated to consonant or vowel, we add a's, the number of a's that is the index of the sentence plus 1. Then we append the a's and ma to result word, and then we add it to a result sentence, and then we return the space dot join result sentence, and that's going to give us our sentence. Okay. I'm gonna run it. Okay, it has passed the test cases.
Submit.
Okay. Wrong answer. Oof.
E should stay, huh? E. You're not capturing upper cases.
Huh. Okay. Okay. Well, I could do this. No. If no. I could do this. I could do this. I think this is the right syntax, or maybe it's lower and then I pass in first char, or is first char like
that works.
falling? Huh?
I think that works. Try running it.
Okay.
You can grab this and then try running it. Nice. Cool.
Okay.
Nice.
All right.
Yeah. I think just keep practicing. Just keep getting faster.
Mhm.
I would say just like, how many questions have you done so far? I would just focus on speed. Especially,
Yes.
you know exactly what to do, but you just need more repetitions.
Okay. What would you think about like my balance between talking? Do I talk too much? Do I talk too little?
I think
Like how am I doing on communicating the code?
it was good, but I would just work on speed as well. Especially, they'll probably want to get you through multiple parts. So,
Okay.
yeah, definitely at the start, I think, yeah, you did a good job talking. The part that I would just be more concerned about is the speed. So I would just
Okay.
keep practicing. Yeah, I think I would just keep practicing because speed is also important as well.
Okay. So were you happy with if I addressed your what you said about appending two strings together being linear time? Do you think this is like kind of the best way to tackle that? Like what I did with having a variable called toAppend?
So you had two append. You're figuring out whatever you're gonna append. You go to append plus. What is this?
Yeah, that
Okay.
I'm sorry about that.
I see.
It's because I'm trying to.
I
Yeah,
think
I'm
it's
trying to
good,
repeat
yeah.
the letter A like I plus one times.
Yeah. No. This all makes sense. Yeah, I think that's a solid approach. Yeah, I would just be able to get it as fast as possible too. That's
Okay.
that's my main thing. So I just more practice. But I think you're
Alright.
you're
Okay. All right.
let me see.
Thanks so much.
No problem. Just checking the chat. So you feeling ready? You
Me?
feeling here? Yeah.
Nah, but that's okay. You know, cause I gotta embrace the struggle. You
Yeah.
know.
Here, give me a question. I'll walk you through how I would do it. Or maybe I can work through this one. Let me see.
Yeah.
Okay, I'll walk you through how I would think about doing this one as well. And then we'll go from there. So I think the same thing. I would first write out the past there and then let's see. I'll probably just begin taking you through my thought process. So let me read the question again. So you're given a string sentence that consists of words separated by spaces. So each word consists of lowercase and uppercase only. We would like to turn it into goat Latin. I mean, give me a different question. Let's see. Throw me a question that you might not know how to do, and then let's see. And I'll walk you
Okay.
through.
Well, I don't know any of the. I guess I don't have a specific question in mind. Let me look through the descriptions and then just pick a random one.
Yeah. Pick one that you worked through recently.
Um. Hang on. Maybe something like with a graph would be good.
At Gabriel,
what-
also, it depends if you're talking about it because somebody said in the chat, the more you talk, the better. But I've seen candidates just talk, but it's not. It's more just they're just trying to fill the void, versus talking and actually making progress.
Okay. Yeah. The thing is, like, I try to talk, but it slows me down. So I'm trying to. I'm okay. I don't know.
I would say
This gets better over time.
yeah. No, I was saying only just like it's fine to be silent when you're thinking, but if
Okay.
I've seen candidates just keep talking in circles, and it's gonna slow them down for sure.
Oh, okay. I recently did course schedule and I thought that was good, but I already kind of know it
Yeah, I've done that
now.
one.
Is there like a similar one?
I think I've done all the variations of that question.
Okay.
Best time to
Okay,
buy.
this one-
Paul's trying to ask me the hardest ones.
Let's see. Is this a good one? It has 3,000 upvotes. Okay, people in the comments love this question. Okay, have you done 1334?
Sounds familiar. This one, the city with the smallest number.
Yeah.
Okay.
Oh, yeah. Have you done it?
Arthav, send it in the discuss. I haven't done this yet, so let me walk through how I do this.
Okay.
So we need to, looks like a graph question. We need to find the city with the smallest number of neighbors at a threshold distance. So there are n cities numbered 0 to n minus 1. We're given an array of edges from weight. This represents a bidirectional and weighted edge between cities. How familiar are you with graph questions?
Okay, so I can do like I'm comfortable with them, but they are I would like to be a little faster in them.
Okay.
I can do basic searching, a little bit of I did learn how to do cycle detection and course schedule, so I kind of want to expand on that.
Okay. So we're given a different weight between the edges and given a distance threshold. Return the city with the smallest number of cities that are reachable through some path and whose distance is at most threshold. If there are multiple such cities, return the city with the greatest number. Notice that the distance of a path connecting is equal to the sum of edges. Okay, interesting. So I don't see a solution right away, but what I would do is definitely try to walk through a example. So Paul's already seeing the answer, but let me take a look. Sometimes I have to read it a couple times. So there are n cities numbered 0 to n minus 1 given the array edges. Where edges? Okay, this is basically just telling us that we're given a threshold. Return the city with the smallest number of cities that are reachable through some path. What's this saying? Return the city with the smallest number of cities. Okay, what are we given? Okay. So we're given a bunch of nodes. So the figure describes the graph. The neighboring cities at a distance 4. The neighboring cities at a distance threshold equals 4 for each city are city 1. Oh look, a bunch of people dropping in their resume. So for city 0, we can get to city 1 and city 2. City 0. But Joshua, what's up?
Okay, I think the example doesn't have. Oh, okay, example 2 has a case where distance threshold comes into play.
It's trying to see how far. So we just pretty much need to figure out how far all the other cities are. Return to the smallest number of cities that are reachable through some path. Okay. Essentially, we're trying to, for every city, we just need to figure out how many cities that it could actually reach. Right?
Yeah.
So what I'm thinking though is it might there's a bunch of hold up. Sorry, I was just reading the chat. So return the city with the smallest number of cities that are reachable through some path and whose distance. Because the thing when I start thinking about distance and there's weights to the graph, I start thinking of like a Dijkstra's algorithm, because I might not be able to reach 3 from here, but if I take a bunch of the shortest paths, I might be able to get there. You know what I mean? So for each one, I can sort of do a Dijkstra. One idea is to do a Dijkstra's from every single node, right? That's one way, but probably another way is, have y'all heard, who in the chat heard of Bellman-Ford algorithm? That might work as well. A Bellman-Ford algorithm will tell you for each node what is the distance between all of the other nodes, and then you could kind of just loop through all of the different nodes. But I haven't implemented a Bellman-Ford algorithm in a long time.
Yeah. So, okay. So I'm reading about it now, actually. Bellman Ford. It sounds familiar. I think some other question has this.
Yeah, what they're saying is right as well. It's a single index. So returns to that are reachable and whose distance is at most. Okay, so this one we have city. The answer is city 0 and 3 because they only have 2 neighboring cities at that. Only needs to be neighboring cities. Wait. Only to be some path. Return the city that with the smallest number of cities that are reachable through some path. Okay, so what we can do is a Dijkstra's algorithm from every single node. We can do a Dijkstra's algorithm to figure out all the nodes that are reachable within some k path, and then once we do that for every single node. That would be like a n. So if we do that for every node, Dijkstra's algorithm would be probably n log n, or Yeah, it would be like depends on how much edges. But let's say, yeah, chat, what are y'all thinking about doing a Dijkstra's algorithm on every single node? But I'm wondering if that's the most efficient way to do this. This has such a high rate. But do you see why I'm thinking of using Dijkstra's or no?
Yeah. Yeah, it makes sense.
Have you studied Dijkstra's before?
It's yes, I have, but I've forgotten it, so I need to review it. But I see because you need to find the shortest path to that neighbor, and it can take like a roundabout way that isn't the direct, like expensive path. So if you're doing the solution where you're doing Dijkstra's on all the nodes, right?
Yeah, that's one approach. I'm just trying to think of one way that's simpler. I guess we can do Dijkstra's here, and if we can reach a node, I wonder if we need to even do Dijkstra's on every single node. I mean, I don't know if it's gonna make it faster, but this is like not a good thing to do. What's Paul saying? N cubed. Yeah. I mean, what I'm thinking is a Dijkstra's algorithm on every single node. Maybe we can just go implement that. Have you ever done Dijkstra's?
I have, but yeah, I've forgotten it. I would not be able to do it from memory or anything. I would probably no.
To figure out this.
I imagine it's some kind of like we search all the neighbors of every node that we encounter. We keep a set of the nodes we visited so that we don't like overlap over nodes we visited. And then if we actually eventually reach the target, we just like return whatever distance we've been keeping track of, like summing up. I think it's a DFS. It kind of sounds like one. I don't know though.
Yeah,
but that's all I remember.
We could even just DFS from every single node. See if we can go 0. And then we could kind of see how far out we can go. I mean, that's one approach. I don't know. This question is gonna be a lot of code. If we do the Dijkstra's. People like this question, you're saying?
Okay, such a wonderful question, truly great. Took me 1 minute to close my laptop and sleep. Oh, I think this might have been sarcasm.
Oh.
Medium, my ass. I didn't read this
How
one.
did it get such a high... That's what I'm looking at the acceptance rate. I was like, if I've never seen a Dijkstra's algorithm have higher than that. I can show you how to implement Dijkstra's real quick. So from city.
Well, people are saying this question is like a waste of time. There's like some bad test cases.
Why is the acceptance rate so high? It's crazy.
Yeah.
Okay, it looks like what we're trying to do. Okay, let's implement this Dijkstra's algorithm. So I'll quickly show you how to do. This one is hard though because it's like. Okay, what we're gonna do is we're gonna start at every single node and pop all of the edges onto that. Let's see what this. Let's just implement this real quick. I'll show you how to do that. You're watching the stream, right? 1334.
I'm listening to you on Discord, but watching the stream. So
Paul, it's
the
pretty
stream is
high.
a little...
It's pretty high. That's just, yeah, Dijkstra's makes sense, Paul. But I was thinking, yeah, all nodes is a lot of work. So what we're going to do is even implementing this is honestly, I don't think they're gonna ask you something this hard in an interview, because when I already look at the rating, it's already higher than the usual one. But I'll write this one down. But I think
It looked easy, but this is definitely a little bit too hard. I think they would
run this in the chat.
like maybe a basic graph question, if anything,
Yeah,
or
yeah,
a
yeah.
tree.
This is like, I don't think I mean, they might ask you this, but. Alpha. I mean, if you want me to write it, I can write out the Dijkstra's algorithm. Okay, let's do.
Okay.
Let's just implement it
I'm
for them.
looking.
Dijkstra's given a node. So we're gonna want to parse out all of the edges. So one thing you need to always do is build out a adjacency list. So it's gonna be a bidirectional adjacency list. So from let's just import. Let's just like quickly finish this. Everyone's saying Floyd Warshall.
Yeah, that was one of the hints of that last one, to use Floyd Warshall's, I think.
So, are you familiar with building adjacency list? That's one thing that you should be able to do real fast.
I think I saw you do it before. Is it's you have a dictionary, and then each key is the node, and each value is just like a list of adjacent nodes.
Yeah, exactly. So we're gonna loop through all the edges, right? The edges are gonna tell us what city connects to the other one, and also what's the weight. So that's important as well. So in our adjacency list, it's pretty much gonna look like we're gonna have a hash map, pretty much like this. So we're gonna say for every node is gonna be in here, and we're gonna store all the neighbors of each node, right? And then we're gonna have a list for every neighbor of each node. So we're gonna say for 0, 1 is a distance 3 away, right? For 1, 0 is a distance 3 away. And we'll store a bunch of tuples like that, where it says the node that it connects to and the edge. So what we're gonna do is we're gonna loop through edges, right? And then for the adjacency list, we're gonna say A maps to, and there's gonna be a cost. So A maps to B. So A maps to B with a cost of that, and we'll do the reverse as well, because it's a bidirectional graph, right? So A connects to B, but B also connects to A, so we need to store that neighbor. So that builds us our adjacency list. And now what we're going to do is we're going to want to perform a Dijkstra's algorithm on this adjacency list. So we're going to be given a node and an adjacency list, essentially. And with a Dijkstra's, you want to use a heap, or pretty much you want to use a priority queue. So we're going to use heap queue right here. And then we're gonna start off with our priority queue, right? So pretty much while the priority queue actually has elements, we're going to do a adjacency list, and what are distance? We're gonna pass in the distance threshold is here as well. Vin, what's good? So now we have our priority queue, and once we have our priority queue, we're going to be looping till that priority queue is empty, and we're only going to want to push elements. We're only going to want to push elements onto our priority queue if we could actually get to that element, right? We'll do some bounds. We'll do some checks before. We're going to only pretty much the priority queue is going to contain cities and the distance that it took to get to that city. So let's say we start with node, and usually it only takes us since we starting at the node, we can just set it to 0, because we're just saying we're starting at 0, right? It only takes us 0 distance to get to where we want, or to get to this first city. So what we're gonna do is we're pretty much going to pop out this node. So equals, we're going to do heap queue dot heap pop. So that pops, or we're going to have to reverse this, because with the heap works, it it pretty much sorts the heap, or it maintains the heap variant using the first index, right? So we'll say this is our distance. So when we pop that out, that's the first node, that's the first city, and we want to maintain some sort of scene array. In most graph questions, you want to maintain some sort of scene array to avoid cycles, right? Let's go scene. Are you still here, by the way?
Yeah. So this is kind of like, yeah, so we're not going to visit a node if we've already taken care of it.
Yeah. We don't want to visit nodes if we've already taken care of it. And then we're gonna keep track of the scene cities, right? So we say our distance, we're gonna heap.pop, and then that's gonna give us our distance, and then we're gonna say for our neighboring cities in the adjacency list, because the adjacency list essentially tells us who our neighbors are.
Mm-hmm.
So we're gonna look for all the neighbors in our adjacency list, and it's also gonna give us a cost right here. So pretty much if the neighbor has already been visited, just like continue, right? We don't want to deal with that case that we've already seen it, right? Mm-hmm. Secondly, if the current distance we've traveled, right now we've only traveled 0 distance, plus the cost is actually greater than the distance threshold, we don't want to visit that candidate, or we don't want to visit that neighbor, essentially. But lastly, if it actually does fit in there, what we're going to do is we're going to probably... the main thing with Dijkstra's is figuring out when to put it in the priority queue or not. So let's just add the scene every time we visit, and then I'll optimize it after, because sometimes that matters a lot. So we have a scene set here, and then we're gonna pretty much, once we visit a node, sorry, did emoji. I do scene dot add that node that I visited. Because that should have been, once we pop it out, that means I should have got there in the smallest distance possible. So basically for my neighbors, if it's in scene, I continue. If it's too far away, I continue. Otherwise, let's pop it into our heap. So let's do heap q dot heap push, and we're gonna pass it here. We're gonna push onto our heap the distance, which is distance plus cost. Sorry. And the actual node, right? And scene cities, we can probably just count here, but at the end of the day, we're gonna return scene cities. Something like that. Let's say print, and then we could just debug it. This is one way to debug it. We can say node has seen cities, something like that. So we have a priority queue, and then what I would do a lot in the interview is also just walk through the code and just make sure I'm doing everything proper. So we have a priority queue, we have a scene set, and I'm not adding, I already noticed right away, I'm adding to scene set here. So we have the first node, and then I'm not incrementing the scene cities, so I'll increment it, I'll increment that by 1, but we're gonna -1 because we don't want to include ourselves. So So we're looking at the heap, we're popping, we're getting the distance, and then we're saying for our neighbors in the adjacency list, if the neighbor is already seen, that's fine. If the distance plus the cost is already greater than distance, we don't want to add it there. otherwise we do heap queue. Otherwise we push that onto the heap. So since it's a priority queue, the smallest one should bubble up. So this is distance plus the cost. The distance would be 0 plus whatever it costs, so that should be 3. And then afterwards we say, yeah, it took 3 to get to the neighbor. And then let's just run this for every single node in the graph and then see what it prints out. Do I or adjacency list. So we pass in our adjacency list and we pass our distance threshold. See what that prints. Wait, so see, 3 has seen, wait, it's bugged out. 0 has seen 2 cities, 1 has seen 4 cities, 2 has seen 3 cities. So I already have a bug in there. Why did it say 1 has 2 cities, 4 cities?
Maybe it's including itself.
Let's see.
Because they're all out. Well, yeah, they're each off by 1. Each of the scene cities numbers is off by 1, I think.
Okay. Let me print out the adjacency list to just make sure that I'm actually building that up correctly. So we're saying 0's neighbors is 1 to 3. You have a node in the heap multiple times the way you wrote it. Yeah. Well, yeah, you're right. He's one of the people in the chat is right. If I've seen a node already, I don't want to count it. So.
Oh yeah.
That's why I might need to flip this. So 3 cities. Let's see. So let me adjust my scene array. Scene node here. Usually I like to do the scene array out here, but sometimes that doesn't work for that case. So we'll do heap. No, this won't work for that case. Okay, what do we get? 2 3 3 2. What is this? 1 2 2 3. So see how we have all the different cities listed out, right? So now we just need to figure out the smallest. Or what do we need to return? If return the city with the greatest number. So what we're going to do is, for every city, we're going to, now after we run the Dijkstra's algorithm, right? After we run the Dijkstra's algorithm, I don't know if it's going to be too slow yet, but after we run the Dijkstra's algorithm, we're able to actually calculate how far each, or how many cities each one could reach, and that looks good. We just need to pick the one that has the largest value, right? That makes sense so far?
Just like as the tiebreaker, or
yeah. I guess what we can do is we can probably sort it at the end. But we could say results. So basically cities. So these are the number of cities. We don't need. Wait, let's see if I want to sort it at the end. But what we can do is for I in range, we can store a max result. Oh, it should be the smallest city, right? So what we can do is let's just do something easy. Yeah, like the same O is going to be the same, But num cities, what we're gonna do is we're gonna result dot append. We're gonna pass in the I, or we're first gonna pass in the number of cities that it could reach.
Mm-hmm.
Let's see. Yeah, the output here is, oh wait, output. Why is the output here 3? Oh, because that's the biggest. That one has the largest. Let's just see. So we're gonna do results.append, right? And we're going to pretty much we're gonna add the number of cities that it can see and the node, and then after we can pretty much sort that. Once we sort that,
okay.
once we sort that, we have them in the right order. We say 0 can hit 2 and 3 can hit 2. Pretty much now we just need to figure out the largest one that's also 2.
Well, that's a cool tip. I didn't know you could sort tuples like that.
Yeah, it'll first sort by the first key, then the second key. So let's just be like smallest. We can do smallest found, and pretty much we'll just figure out. We'll just keep track of this. We'll say min of. So at the end over here, we should know the smallest found. Print is 2. Right. So basically, what we can do is we can filter out all the ones that are not equal to 2, and then we could just sort it backwards. I mean, like we're doing a few passes to it, but that, I mean, we could probably do one more pass to it. We could say for lm in result, right? Let's do right for element in our result if the index equals 0, or if the index is the last element is equal to the length of result. And all I'm doing is literally trying to print out this last one, but you want to basically what I'm going to do is I'm going to look ahead, or I'm going to look for the last one before it changes to something other than the smallest one that we found. So basically if the index is equal to the length of result minus 1, or because if it is, then or we look at the result, so index plus 1 is not equal to Paul. Yeah, they ask it. Or the result is not equal to smallest found. Something like that. Wait, how did that return the wrong thing? 53. Oh wait. Oh, sorry. I have to do element 1. Wait. What's the result? 2023. So if the index is equal to the length or the result. Oh, sorry. Result. Something like that. Nice. Damn, that was crazy. Are you still here?
Yeah. Wow. Okay, well, so why is there such a high acceptance rate?
I have
for
no
this
idea.
question, do you
But
think?
I think how
It's
I
like
break this down is with a lot of the graph questions, you want to grab and y'all, I'm a little bit off some beer right now. I'm not gonna lie. But what's it called? You need to build an adjacency list. That's like automatically know right away. Automatically know how to build adjacency lists in multiple ways. There's like 3 4 different ways that you can do it, but yeah, Dijkstra is using a priority queue. But the one annoying thing is, I don't like how, yeah, well, yeah, seems to depend on how complete the graph is. But yeah, you have any questions on how I would approach that? Do you see like how I kind of would walk through it in the interview?
Okay, I think so the part about Dijkstra's that maybe I would have missed it, like if the interviewer asked me to just implement Dijkstra's straight up, I would probably forget about the priority queue because that's like not something that I carried over in my memory. But once I study it, and like some other graph algorithms, I'll probably get a better understanding of it. I had a question about like how you were debugging.
Yeah.
So let's say that I actually there's like a bug and I'm trying to find it. Like what extent am I what's the best way to do that, handle that during the interviews if like
Yeah.
there's like some bug I'm trying to find.
I mean, for what I've seen, only the FAANG companies won't let you run your code. Like Meta and Google, they'll do it on an editor and they won't let you run your code. You kind of have to walk through it and step through it. But a lot of the startups still make you finish with working code. So if you need to debug it, you can debug it the same way I did it right now, which is literally print statements. Because at the end of the day, you want it to get running code. You want to get running code by the end of it.
Okay, so if you're allowed to run it, then I guess try to fix it like with that similar process.
Yeah, similar process. Figure out, like, you see the way I was kind of breaking down. I was like, let me see if my adjacency list is working properly first, and then let me check all like some of the other stuff.
Would I be able to just let's say that I just implemented the adjacency list part. Could I just like stop for a moment and like check to make sure it works? Is
Yeah,
that
yeah,
okay?
yeah. You could do it. Here, let me give you another question. One good question just to see how you work with the graphs. And
Okay.
chat, if anybody wants to do a mock, just type it into. Otherwise, we're gonna keep prepping this guy up for his interview.
Yeah, thanks so much. Okay. I'll try to be faster this time. Maybe I'll only talk if it's like something that's substantive. And um yeah.
Okay, let me look for. Have you done 199?
Um no.
Okay, I'm gonna send you a link to this.
Okay.
And then walk me through the whole process. I'm gonna send you this link.
Okay. Okay. Um, Given the root of a binary tree, imagine yourself standing to the right. Return the values you see, order from top to bottom.
Yep.
Okay. Okay, I could do so this case example 2, that's I'm taking a look at that one. Um, we could do a level order traversal, and just whatever is the last node in that level, we can just append that to some kind of running list of rightmost nodes that you can see, and then we can return that. That would be bad if there's maybe a lot of nodes hidden, like just like a lot of nodes would probably slow it down a lot. Let me think a little bit more. Well, we could do a DFS. Well, yeah, well, we could just go down the tree, try to get to the rightmost uh, child that we can at every step, and then once that runs out, how do we, how do I, in example 2, I need to find out how I would jump from node 3 to node 4. I could, okay, I could keep track of, hmm, hmm, how am I gonna find 4? Um, okay. I think I'm just gonna go for the level order traversal solution. So,
Oh, sorry, I was muted.
oh,
Oh, I was muted in the chat. Yo, chat, how long was I muted for? Oh no, I think I just muted a second ago. I thought I was muted during
okay.
that Dijkstra's algorithm. That'd have been.
Oh, no, you weren't. Yeah, I just kind of, I'm trying to figure out how to get from 3 to 4. So, if you had any, like, if you were trying to say something during that, but otherwise I said that I was going to just go with the level order traversal.
Yeah, let's try it. Let's see. That makes sense. Let's see. Just try to implement it, and then try to focus on getting it done fast too.
Okay. So, okay, so first we're gonna have a results list. We're going to, this is just like our output. Okay, we're going to go through each level. To do a level order traversal, I think we can do queue. So let's go ahead and import uh, collections. Okay. Um, so we're gonna have a queue, right? And then to do our level order traversal, we start up a queue. We put our root into there, and then we we pop from the queue. We look at its children, and if if it has children, we add it back to the queue, but with some kind of indicator that it is the next level. So
Yep. Yo, chat.
so
Chat. Type in the chat if you know how to solve this with a DFS. I wouldn't do it with a DFS. I'm just saying.
okay. Yeah, because I don't know how I would jump from 3 to 4 with the DFS. Anyway, so 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 our so we have a deck. So this is our queue of nodes, and then got I think it's append here. I don't know. Okay, queue dot append, and then we're gonna put in 2 data points here. This is our current level, which is level 0, and then here we're going to add the roots. So while queue has something in it, this, we'll do like current node equals, you just like pop from the left of the queue.
Mm-hmm.
Then we are going to look at its children. So node.left. So if node.left, then we're going to add it back to the queue. And then we'll increment level, or okay, actually this is level. So we need to, so when we pop from the queue, we get node and level, and then we just add 1 to get our next level. Okay. Then we do the same for right.
Let's see where you're at.
So, okay, and then I need some indication that we've moved on to the next level, and that we when we pop this and we find that so our current level is 0, right? And if we suddenly pop a new node from the queue and it's suddenly the next level, so different from current level, so if our new level is different from current level, and then also this is going to start from 0. To be clear, this is going to be greater than current level. Then we need our current level to increment by 1, and then we're going to trigger the behavior for a new level. But to do that, what we're going to do is, well, we would need the previous node that we just got from the queue. So yeah. We need the previous node. So once we're done with this, we set previous node equal to node all the way at the end, so that when we go back to the top of the while loop, we can compare previous node to our current node. So we're going to append previous node here, and then we return the answer. Let me go back and make sure. So
Okay, yeah, you're implementing nice and fast. Okay, let's see result.
yeah, so this is my level order traversal. To walk it through,
Sure.
we're gonna have this queue, and it's going to have a tuple with the node and also what level we're on. We're gonna keep track of what level we're supposed to be on, or were previously, and then we also have like previous, our previous node. This is going to, so we start from the root, and then we first see if this is a new level. So if this new level is greater than current level, then we append this the rightmost node that we encountered previously. Otherwise, we just add the rest of them to the queue and then increment level because they are the children. And then we set previous node to node so that it can, so in case this is the rightmost node, the next while loop can add it to our answer.
I see.
Okay, I'm going to run it, I think. Well, actually, wait. I need to. I'm supposed to append the values actually. So yeah, it's that actually. Okay.
Yeah, I like it. It's looking good.
Okay, I ran it. I get. Oh, I forgot to check if they're null.
I mean, that's what you're doing right there, right?
Yeah. So, well, yeah. Well, if node itself is null, so if this is, so I'm adding null. I'm adding empty nodes to the queue. That's. Why am I doing that? Where am I doing that?
Well, you probably just need to handle this if just the very first case right there.
Oh, interesting. Okay,
Okay, it looks like it's not doing the right thing though, so let's debug that.
sure. Node. So yeah, none type object has no attribute left. Node is none. That's a problem. Node is none.
Or should this be equal here?
Um. Uh. Well, no, because we don't want to do anything for like any of the left ones. For well,
Or I mean like this.
oh,
What's this? I don't know.
okay.
Just get.
Okay.
I'll rewind it though, so you could debug it yourself. So what's happening? You're getting 1, 3, but you're not getting 4, right?
Wait, I can't see that test case. I'm gonna
Yeah.
hop on the screen.
Oh no, run it for yourself. If you
Oh,
run it, you don't see it.
well, when I run it right now. Oh, okay. Wait, it's different now. Oh, I didn't see these before. Let me take a look. I'm missing the 4 in case 1. So 1, 3, 4. Okay. Yeah, because I need to add previous node to results. So I need to add previous node val. I always forget like the last remaining condition at the end of a while loop. But I think this is an improvement. So in the case where previous node equals node. Yeah. So this takes care of the very last node, the bottommost rightmost one. Okay. Okay. This could be it.
Nice. Good job.
Nice.
Cool.
Okay.
Yeah.
All right. Well, how did I do on this one?
Yeah, I think it was definitely good. It looks like you're strong with the graphs and trees because you're able to implement that one a lot faster than the string one. And
Okay.
you
I was just less nervous now.
Yeah, that makes sense. But yeah, I think you walked through everything properly. You implemented. You're using good variable names. So yeah, I'll give you a pass on it. I'm not sure what the priv node is.
Oh, great. Okay. The first one would have been a fail, you think?
Let's see. Probably just for time.
Okay.
But I'm a hard
All right.
interviewer.
No, this is good. So, all right. So, because I had a question. Um, yeah. So I think maybe I should lean more towards trying to just write something, even if it might be wrong.
No.
But what if it is?
Don't definitely get it right, or talk about your approach.
Okay.
Talk about your approach
How do-
first, and then make sure that approach is right. But I think for easy questions, they would expect you to get to it faster. And the only way to get to it faster is just having done a lot of lead code, essentially, or just have a lot of
Okay.
practice.
How do I get a good sense of when is a good time for me to like just start coding, or like how do I get a feel for if the interviewer is on board?
Yeah, exactly. That's a good question. I would say describe your approach, and usually I get a pulse check. I'll be like, how does that sound to you? And if they're like, yeah, that sounds good, I'll be like, okay, I'll just start
Okay.
implementing then. But if they don't get it, then they're gonna be like, I don't get exactly what you're trying to do. Can you explain it? And then, yeah, that's pretty much. You just need to always be checking in with the interviewer too.
Okay, so I'm like, okay, so I say stuff like, does does that make sense, or
Yeah,
do you
but
agree?
yeah,
Okay,
exactly. Like, do you understand what I'm trying to do here? And then once they understand what you're trying to do there, then you get to move on. If you Yeah, and I'll just keep checking with the interview. Obviously, not too often because it slows you down. But in when you, but just it's all about you have to look at the interviewer too to see if he's understanding what he's saying, what you're saying.
okay.
And yeah,
They usually have their cameras off, I think,
oh
at this
really?
company, but
I mean, yeah,
so it's like all like this disembodied voice, and it's really hard to read.
yeah. No, I think good job with it. I would just keep practicing. That was a medium you solved it pretty quick.
Yeah.
I would just keep solving more questions and just work on my speed.
Okay. Was this possible with DFS?
Yeah. Let's see. You could do a DFS. Essentially, what you could do is you can DFS from the right. What you can do is DFS, but look at the right side first, then look at the left side. So that allows you to, cause you know how, are you watching my stream?
Oh, well, let me hop over. Yeah.
You know a regular DFS, it'll make you
hmm
go this way, then it'll go this way, then it'll go this way, then it'll come back up, it'll go this way, right?
Oh, okay. Yeah,
So
yeah. So
essentially,
so we do the opposite, but for the right,
yeah.
and then if we run out of right nodes, we go back to the whatever route we can get to, and then we just go to the left one, and then we do the same thing from there. Try to find the rightmost node from two or something.
Yeah, and we could actually implement it here. I'll show you how it's done. If so, pretend we have a result, right? We start with our result. So essentially, what we're gonna do is we're gonna have our stack. You always want to capture the base case. So if the root is actually none, we return empty. But what we're gonna do is we're gonna want to DFS. We're gonna want to DFS visiting our right child first with our left. But that doesn't matter when we're doing it. Stack equals root. It doesn't matter if we do it iteratively. That's actually how it just works out the box. So if we do it iteratively, right? We add one here. We'll look up. We'll add the depth. We'll basically do node depth. The depth is actually 0 here. If we have the depth and we do stack, you know how to do it iteratively and recursively, right? All these questions.
Um, I mean, for a BFS, that would be I usually do it with like a queue of some kind, and then for DFS, I just usually do it recursively.
Yeah, I would know how to do it with both. But I'm gonna do
Yeah.
DFS with a stack here. So basically, if the depth is equal to the length of the result, that means it's the first time we ever saw something in this depth. We do result.append that node, right? So since we're going from right to left, that's what's happening here. And then we basically just say if node dot left, then stack dot append node dot left. Otherwise, if node dot right, we do stack dot append node dot right. So you see in the stack, it puts the left first, then the right next. That means when it's gonna pop it out the next time, it's gonna actually look at the right child first, right? And then we need to make sure we add the depth plus 1 here. What complain about? Oh, we want the values. Return the values. Okay.
Oh, okay. So I just switch it from a queue to a stack. Makes sense.
That's one way to do it. You can do it at DFS. But yeah, I like both ways work. And
Okay.
you can get this variation in left view, right view, and there's even a question called vertical view. If you see from the bottom, which is like all types of views.
Oh, bottom view could be interesting. I might do that after
How do you think we
after I
could get
hop
the
off.
bottom view?
Ooh, okay. So, hmm. We, well, ooh, well, the bottom view. Let me see. Um, well, if it's does that block the view of like 3 in your example?
2, 6.
I would need a diagram. Let me.
Yeah, I'm diagramming it right here.
Oh, is that how the question goes?
So basically, you just need to figure out the column, and then you need to basically figure out, like, group them all into columns, and then just look at the one at the
Hmm.
at the lowest row of each column.
Okay. Let's see. I'm reading your chat. I like the get x y axes solution. That's maybe something I would do, and then we group it by whatever x is the node, and then try to find the highest, or I guess the lowest y. Yeah, so then the root would be 0, and then the left would be like -1, and then anytime we go right, we add 1. Anytime we go left, we subtract 1. That's how you get x. And then y is you just add 1 for at each step of the search.
So actually, yeah, if I was looking at this from the bottom, the binary tree from the bottom, you have to draw it weird because it kind of overlaps like that. But I would only see 7, 2, and then 4. But yeah, there might be ties. You're right. So that would be a question to ask the interviewer. Maybe the interviewer would be like, yeah, maybe the interviewer might say that you take the smaller one or something, or return both because you can see them, they're at the same level. there's also viewed from the top, right? You can view this thing from every direction. It's pretty funny.
Top would be, I guess, leftmost and strictly only left, and then plus. No. It would be. Yeah, it would be leftmost, and then I would try to keep track of the x coordinates for that, because maybe there's like some zigzags, and then rightmost for the right side, also keeping track of x coordinates, and then I would group it again by x coordinate, and then just find the top one of that.
Yeah, that makes sense. Yeah.
In case there's zigzags, a lot of zigzags would be, would have like the groups.
I think
Be quite big.
your problem solving skills are really good. I would just work on the speed. That's the only thing. And
Okay,
that's all just
yeah.
practice. Like you're able to. What year are you in? Oh, you're about to graduate.
No, okay, yeah. So I graduated a long time ago, like 4 years ago from
Okay.
undergrad,
Nice.
and I just been with a non-CS degree.
I see.
So I'm kind of mostly just like going between various odd jobs, and then I found my way back to coding because I rediscovered my love for programming recently. So I've been trying to get back into like computer science.
I see. And you have a computer science traditional degree as well? Oh no,
No.
none. Yeah. So you're pretty good then for not even doing the.
Yeah, I wish I was like on this grind way earlier. I mean, this is on top of being a lot of fun, it's like really useful skill. I just feel like I'm so behind right now, but I can't get that time back. I just gotta do the best I can by Wednesday. I know my chances are not that, but I gotta give it my all.
Yeah.
Yeah, it's a miracle. I'm getting interviews actually. I'm hoping
Some people don't, so I just keep
I'm hoping
applying.
to get. Yeah. Yeah, I'm casually applying. It's all good. This is just like a really cool opportunity that fell on my lap, and I want to do the best I can.
Yeah.
Let's see.
What is this? Looking at this one question, rotating the box. Are we allowed to make a copy here? Let's see. "90 degrees clockwise." I mean, yeah, we probably could make a copy. That's kind of a dumb question. So let's make a copy. What are you thinking, Jay?
I need to read the question. 1861.
Do it in place. Yeah, the dimension swap. How are we gonna do it in place?
Okay, I'm still reading the question. So, okay, 90 degrees clockwise.
Oh, I mean,
Oh, this question's really interesting. Okay. So we wanna just rotate it and just simulate where each of the objects lands. Well, okay, I think the examples are a big hint as to how to do this.
Okay, you can
So
kind of or keep thinking. I'm trying to think of some approaches too. But like Satvik, like if we don't, I mean, if we could add buffer to it and then flip it, then remove stuff, but that just feels off. I mean, like why not just create a copy at that point? So I'm thinking all we do is we figure out the dimensions and then we create another box with the dimensions, but as if we rotated it. So the number of columns here becomes the number of rows here, and the number of columns here, or sorry, the number of columns here becomes the rows in the next one, and the number of rows becomes the columns of the next one. And then pretty much we just have to start filling it in. I mean, alpha code, is it really in place if we're... No, I guess it is. Yeah, what we can do is we can add a buffer to it and then delete it. We'll have a bunch of empty slots. Think like if we rotate, what will happen to a column and if there's an empty slot?
Okay. Does it say anywhere we got to do it in place?
Well, I guess... Yeah, we can do a bunch of swaps. Let's see. Bro, this is actually complicated. Oh wait, oh no, it slides. Oh, I didn't even read this properly. When you put it 90 degrees, things slide down. Okay, I didn't even see that. Okay, this is a good question. Bro, how's every leak code question have such a high percentage pass now?
Oh, are these like newer ones that have higher percentage? I don't notice these patterns. I don't do very much leak code,
Yeah,
but it's
but yo,
interesting to see
I'm
like
actually
how
impressed
it's
that
layered.
you never did comp sci, and you can do these.
I did it in high school, and then I just kind of abandoned it for a long time. I'm gonna try to just copy it onto a new grid and see where that gets me.
Alpha
Yeah.
code. Did you see? I ran one on a Berkeley student. He was okay. Let's see. Okay. So what I'm gonna do is create a copy, right? Let's create a copy, and then just start moving things. So let's create a copy with the different dimensions, and then pretty much just move from left to right on the row here. So if it's this, kind of like a 2-pointer. So we just need to figure out. Alpha code, did you already drop your resume in the thing? I can look at it. Where is it? Yeah, drop it in the Discord. I'm not a recruiter though. Satvik, you good if I make a copy here? Or that's a strong no hire? Yeah. Okay. So I'm going to figure out the rows and columns, then I'm going to make a copy. Okay, let's row. The rows, columns, rows. That's crazy if they push it in place. I bet Meta would do that. I feel like they love doing that. Box grid length.
I mean, your solution for that didn't seem bad. Just like make it a square, I guess, first, and then rotate it, and then delete the whatever. Yeah, delete the columns.
Noor, what's an in place? Noor, it means like don't make a new copy essentially. That's what he means by. That's what they mean by in place. So I'm gonna build a copy. For row in range rows. We'll do yeah. What Savik said. Oh shoot. We gotta flip this. Yeah, no problem. Go walk your dog.
Okay, I'm gonna try to do it on my own without looking at yours.
Yeah,
and just see if.
Go ahead. Oh, there's even boundaries. Interesting. There's even obstacles. I like this question. There's even obstacles there. So we'll work from the bottom of each one. So let's do... do for the different rows. They're gonna do index equals calls -1. That applies here. Alpha code sounds good. I'm gonna take a look in a sec. So we're gonna work from the bottom up. For column in here. So I'm accessing a specific column. Oh no, but we need to work with the old one. Okay, this gets a little bit complicated. So we're looking at the old one. So let's start from range row at the very bottom here. But at the back. So we need to start at the back. So we need to start at, so we're gonna start for range in rows. -1, -1, -1. This is the row we're looking at because we're trying to move this. What's up? So we're at a specific row here, and then we want to work from backwards on this row. How does that give us what value to look? Because we're gonna have we're gonna need 2 pointers. We're gonna need 1 pointer. Pretend we have this. Let me just draw it out. This actually gets pretty trippy.
Wait, what are you working on right now? Are you rotating the array or are you on the second part?
I built a copy already. Now I just need
to fill it in?
Yeah, I guess.
Okay, I think I have something for that, but I'll show you later.
Yeah. Keep going. Where did the walls go? We need to figure out an algorithm. We just need to flip. Check. Nice. Honestly, I'm just responding to the chat. There's a lot of opportunity. You should switch if you really enjoy it, if you like it. Alpha Code, you don't like the AI? I'm a fan of AI, honestly. Do you think we have AGI soon? I don't know. It's pretty scary. I think we're very, very close, honestly. Okay, to find where it's going to be, we just need to flip the row in the column. So when we make a copy, let's just flip the row in the column. So let's just say for I, then we'll say for I in range rows, for J in range columns, what we're gonna do is we're gonna say copy of grid at, we're gonna put in J I is equal to grid box grid at row I J. Should get us what we want there. But with some empty slots. What's the... And then now we just need to do... Alpha code. Are you sure about that? Let's see. Yeah, it is. It's actually up there with the best human coders. Yeah, Alpha Code in O3 went crazy, and they scored really high. I have a video on this. Went crazy. So we do. Now that we copied it over, now we just need to. Pretty much shift everything down. So how do we shift it down? Is we start from each of the columns. So let's say for column in. Pretty much for column in range the length or range in the length of copy yeah, you shouldn't move the obstacles. It should stay. So we have for column, we're gonna loop through. Now that we have it here, we pretty much need to loop through every single column, and we're going to start from this one. So we're going to do for length of copies 0, right? And then what we're going to do is we're going to start at the very bottom row. For J, or sorry, for row in range. Then we start at the bottom here, which is the length of the copy grid. One, minus one, minus one. So we go minus one, minus one, minus one, minus one. Next open equals if yeah. So we're working from the top to bottom if it's equal to if the road is equal to a hash, or sorry, what is a hash? A stone. Then what we're gonna do is we're gonna do next. We're gonna do copy grid. We're gonna go the next open at our column equals that. And we say empty now. And we do next. Yeah. That's what happens if it's a hashtag. Elif, it's a space. We just can continue. But if it's a stationary object, if it's a stationary object, if it's a stationary object, what are we gonna do? We do next open row -1. What do I get? Veneer, you can. The best way is probably through a top university, but if you go through a boot camp, you'll eventually get there. If you just work hard enough.
I know someone who has a boot camp, but he doesn't really know where to go from.
Oh, but he got to
where he is.
OpenAI next open. And then he works at OpenAI. Yeah, why am I not deleting one? I should have moved it. I should. Wait, chat's asking you something, Jay.
Huh?
The chat's asking you something.
What? If he works at OpenAI. Wait. What? If I want to work somewhere like OpenAI, well, not. Oh, is this the guy I know who did a boot camp? No, he doesn't. He doesn't work somewhere like OpenAI. He's like in somewhere, I don't know. It's like kind of software adjacent. That's where all the boot campers are. They're kind of working like software adjacent right now. But I mean, okay, so every single person has mentioned my lack of CS degree. Everyone has mentioned it.
Really?
Degree at a university. Yeah. Well, they like not directly, but they want me to talk more about my education, and then when I talk about it, they're like, oh, okay, so how did you make your way towards like programming? They asked me a question about that.
I see.
So it's definitely super noticeable. Um, it's probably like a barrier to for some companies. I get auto rejected because I don't have a computer science degree.
I see. That's
University is very important. You need the degree. It's not like it makes it a lot harder, I think.
Who's writing into here?
Well, they're okay. I thought degrees are
Point to
irrelevant
next
for
open.
big
Can you
techs.
think of swapping it?
They-
What you're seeing at RC?
I mean, I've heard of people who got jobs at big tech without a degree. They usually, maybe not like these days,
Yeah,
but
it's
it
changed
might have
up,
been
huh?
more common.
It's changing up, huh? Okay.
Yeah. Yeah, I think
Oh,
there's a lot of competition still. I think the job market is a little better. I've been like this whole thing started in November. I was like not even considering applying. I was like completely happy, but then some recruiters started like hitting me up suddenly on LinkedIn for the first time in years.
yeah.
So yeah, I took like an interview. One of them was a different
Yeah, where are you
like
interviewing
quant
at?
firm.
Quant firm sounds
Um,
sick.
Yeah, I mean that's like it does sound sick. I mean it's like you get to I think in quant firms you can actually work on really cool stuff, whereas at big tech, sometimes there's like a maybe some more bureaucracy that kind of and maybe the work gets a little repetitive. I don't know either way. Either would be great, but it's just like what's available to me. Um, okay, I think I don't see a reason to do anything with the asterisks, the stars. I just have this case where I have like a hashtag about to fall onto a period, so I just swap the two, and then I move uh from the bottom of the column, just like process. Oh wait, actually, mm,
Oh wait, I'm not even flipping this properly. So the
what do I? I'm trying to move all of these down.
row 1 0 1 1 becomes 1 minus 0. Wait, what is this? 0 1, and then this is like 0 0 0 1 1 0 1 1. What is
Okay,
this?
someone in your chat asked, if you know someone from the inside, would it be easier to get into a company without a degree?
Probably.
At my company,
Or go ahead.
referrals are pretty useless at my company I work for. It's just the yeah, I've never had a referral work or get anywhere. How long did it take you guys to get good at coding? How long could it take someone who's not computer savvy to get good if they were dedicated? Okay. Well, I'm not really good at coding, but I'm not scared of it anymore. So I think to get to that point, uh, honestly, you could probably like get really comfortable coding some stuff in like a week or two. I think you could start with like for loops, just like for loop challenges, like finding the max of a array, starting from there, and then build up the complexity. I wish there was like a problem book that kind of started from the beginning,
Yeah.
like maybe leak code, and then just like really basic CS 101 questions, all in one ordered workbook for you to go through. I wish someone had that, and then you could just like work your way up. Oh, I have to know the Linux shell, possibly. Because they asked me that in the OA. They asked me
really?
questions about like Linux. Yeah, they were like
Dude,
they
that's
were like
crazy.
quizzing me on the various arguments for grep and
Yeah.
ls.
Dude, they're going crazy. You already know them? So one
No,
zero has to become 0, 0. What the frick? How does that work? 1, 0 becomes 0, 0. I need to flip. You can't just flip them. I was just flipping them. Oh, actually, I just need to reverse each row. Dude, this is... I'm cooked right now.
okay, what I did is I just did like a backwards for loop or like inversed for loop. Oh, actually you have that too. Never mind.
Yeah, I have a backwards for loop coming from the back. I reversed all of these. What do I get here? Okay. Now I'm just doing these pointers wrong. Yeah. Okay. We start at the next open, which is the length of copy grid. So that brings us at the bottom. So while we're moving from the bottom, if the row is equal, so let's just work through this example because we're not moving it through. So we put our next open there, and we're gonna loop from this side. This is our column. No problem. Thanks for hopping on the stream and subscribing. Hope to see you around, and we'll drop more coding content for you. Shit. What's my result? Oh, I did move it down. Zero, 1, 2, 3, 4, 5, 5, 4. The heck is it this? So we swap. Oh. Wait. If the copy grid at the specific row and column is equal to, if the copy grid at the specific row and column is equal to a dot, if the copy grid at, we don't move it. Wait, let me just check this out. You have to copy grid. Shit, I'm actually cooked right now. I don't know if my brain is working. I might have to come back for this tomorrow. Okay, wait. So
Okay, I'm close to something, maybe.
nice. Let's see. Or wait.
Okay. Uh, how do I?
Or just tell me what you got. I'm just quickly
Okay.
finishing up mine to see.
Okay, I'm.
Let me clean this up because I'm just not doing this properly. We're essentially. Let me stop adding so much test cases. Okay. Let's just do it with a 1D array quick. Just do. See. Let's work from the back here. Let's just focus on 1D array, and then I'll figure out the other one. So we're going here. So next open we say is the length of the ends. So 0, 1, 2, 3, 4 is equal to 5, right? We have our right pointer, or we have our other pointer. If it's equal to dot, we pretty much don't do anything. Move right. If it's a hashtag, we swap this. But where do we put the next open? Becomes where our pointer is.
Okay, I keep getting wrong answer. I think I'm turning. I think some of my hashtags are randomly disappearing. And okay, I think yeah, my brain is fried.
Bruh,
There's no
I've been on this stream
way
for
to fix
5
this.
hours. I'm fried too.
How do you do this so much?
And I was leak. Bro, I'll show you how many leak code questions I did today. Submit a bunch. Probably solved like 10 questions today.
Oh wait, let me see what mine looks like.
Track your loop position. Yeah, I'm tracking my loop position and the next open.
Okay. Let's see. So I did. I've done 100 leak code questions. 32
Nice.
attempts.
Shit, I'm cooked. Okay, my next open, right? I swap it, but where'd I put the next open? I put it where my current pointer is. So I swap it, then I put the next open where my current pointer is. Right. So here. 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 Or sorry. Let me rewind it. Sapvik, what am I doing wrong there? So I start a left pointer here and I work both of them from the back. So I have the next open and I work this one from the back, right? So pretend this was a space. So this is next open, right? Next open is equal to 5. What I do is I flip it. Or since it's a dot, I move forward, but my next open doesn't move. I see. Oh, wow. Hyper Ultimate is good. Bruh. I wasn't thinking straight. That's a mega fail. Bro, I might have to clock out the stream soon. Bro, Sadvik, let's talk though.
Yo, thanks for having me. This was
Bro, I'm
a
gonna run
huge
this
help.
again soon, man. That was a crazy 5-hour stream. That was nuts. I ran like 10 mock interviews.
Yeah, the longest one was with me. So I got a lot of help out of this. Thank you so much.
Yo, we'll do it again tomorrow. I'll hit you up. I'll message you. I got you already.
Nice. I appreciate it. I found like a long lost friend, and he's the only person I know who can do a mock interview for me. So I'm like reaching through the depths of my past to find people to give me mock interviews. It's so hard to find.
Yeah,
like,
awesome.
A lot.
Tomorrow I'm probably gonna grind more questions that are around probably 1600. I was doing a lot of questions between 1600 and 1665 rating. 1600. So I'm gonna continue around
What is
those.
this website?
It's called Zero Track.
Zero Track. How does it score?
It scores based on like contest rating, so it's actually really nice. I like it. And sorry, chat, if I got tired at the end and I couldn't explain my approach, but we're gonna grind out some more stuff a different day too. Thanks for everyone for hopping on.
Okay, thank you. Good night.
Yeah, good night, man.
Good night.
Nice, sick. I like how y'all are also doing it at the same time. At Zatvik, hit me up. We'll do a mock tomorrow. Let's do a mock. Let's get you prepped for your meta. Alright, catch you on the next stream. Wait, I just need to... Don't worry, Aries. I'll tell John. Okay, catch you on the next stream.